Is my screen visible? Okay. So, as you know, you might have, went through a couple of algorithms yesterday regarding maybe some regressions and some classification methods. So, I don't know, like what data set, you have used, and maybe, most of them might have, labels. So, for example, if you have dealt with, can you please tell me, what are the examples you went with yesterday? Because I'm not clearly aware of those information. Some examples. Is anyone typing? Was there any specific data set used? Just for an example, I would like to know, what uh, data sets you used, so that I can use that an example and start my session. Oh, okay. So that's something somebody messaged that they've used wine quality. So in wine quality, or maybe so in the data set, this label might have been already provided. Okay, so in that case, you'd have demonstrated, performed some operation classification. You might have classified the data set into different quality of wine, maybe something like that. So, for example, you are working with some situation where you are not aware of the labels. Okay, you just got data, and as you can see in the screen. So, for example, whatever you're seeing in the gray color is the data which you have got in the what is it for some operation. So this data we have to categorize, or maybe we have to cluster this data into three separate sections. So in that case, we don't know what to start with, right? I mean, we cannot just cluster them as we see. So maybe as you can see that it is kind of formed into three clusters already. But is it the good method, or is it the good way of clustering? We don't know yet. So what we will do is we will use some mathematical help, and we will go with some steps through which we would be able to categorize this data. Okay, so k-means is one of that. So actually, what we are going to do is we are going to follow a couple of steps. I mean, it is kind of easy, and we are going to follow a couple of steps. And at the end of this, we are going to have the data categorized into three different clusters. So, for example, when you are going to deal with some unknown data, for example, maybe you have got some, for example, let's say COVID. So maybe if there are some clusters to be identified, so all these details would be you'd be given all this data, but you don't know what to look for. Okay, so maybe in some applications you have to categorize this, or maybe you have to not a classification, you have to cluster this data into three or four, or depending upon the categories. So we are going to see that how it is done is we would use the Euclidean distance. I think you already know what is Euclidean distance. um, can anybody tell me what is Euclidean distance? Do you guys remember something do you guys remember something let's say, for example, we have point A and point B here, and if you want to find the distance between these two, how will you find that in a 2D? You want me to explain about this also? Okay. Somebody mentioned that, like the Gautam Krishna mentioned root of x2 minus x1 square. Okay. So finding the short distance of element. That's what we are trying to do here. Okay. So what we have to do is, like, we will use this concept called Euclidean distance, and that will be the base of this, and we will try to cluster this. So for example, like, let's say the following data whatever we have here. Okay. So the following data whatever we have here is of the of this shape. Okay. For example, like, let's randomly select the cluster as 2 here. Okay, let's randomly select the cluster as 2. So what I want you to do is, like, I want you to identify two random points here, and then we will try to categorize this. So for example, what we are going to do is, like, as you can see in the screen, we are going to select two random k points. Okay, so this is going to be the center point of the cluster. So for example, here we have selected one blue color cluster center point and another red color cluster center point. So using this method, how we are going to cluster this information is based on the Euclidean distance. So what we have to do is, we have to assign. So as I've mentioned here, you have to assign each data point to the closest centroid. So this is the centroid which we have considered here for the blue cluster, and for the red cluster we have considered this as the centroid. Okay, let's randomly select that point. And then when you're going to consider this as a centroid, what is the next thing you have to do is, you have to calculate the distance between, you have to calculate the distance between these centroids. Sorry, the data point and the centroid. So for example, like, what you have to do is, you have to calculate the distance between this what do you say, the data point, this given, this is the data point, and this centroid. So how, since there are, like, two centroids, so what you have to do is, you have to calculate distance between this data point and centroid, and you have to find the shortest distance to each data point. So that's what we are going to do. So for example, like, when you find the distance, for example, this data point is closer to blue, since, like, we will mark it into the blue region. So when I consider this data point, is it closer to blue or is it closer to red? It's clearly visible that, like, distance between this data point and the centroid red is much shorter than the blue one. So what we will do is, like, we will categorize this into the red category here. So into the red category. Okay, and similarly, like, as we are going along, for example, like, we consider this data point. So by measuring the Euclidean distance between the blue data point and the red data point, we already know that this is close to the red data point. We will again classify this into categorize this into the red data point. So similarly, like, when you're done with this, when you're done finding the distances, you will get to know that, like, so few points that already belongs to the red data point, and the other points, like, belong to the blue, maybe blue cluster. So this is how you find the cluster. But now the whole point of, like, and how to say that, this is the clusters that we can find out. The data. That, like, we were able to cluster this data into two sections here. So one into the blue region and another one into the red region. Now what we have to do is, like, we have to identify an imaginary line here. For example, like, see, this is the line which separates this data as which is mentioned in the bottom image here. Okay, now after this, like, what we have to do is, like, we have to identify the centroid of the newly formed cluster, because there was no cluster existing already. We imagined that, like, this could be the centroid of one cluster and this could be the centroid of another cluster, but turns out it was not the case. So what we should do is, like, we have to find the distances, and we have to cluster them into two clusters already. So once we find that these points belong to this cluster and this points belongs to this cluster, the next thing what we have to do is we have to find the actual centroid of this cluster. Now these points, whatever the blue points you see here, has been already clustered into this section, and the red points have been clustered into this section. So what we have to do is we have to identify the new centroid. We have to identify the new centroid of this cluster. Okay, we have to identify the new centroid of this cluster. That means see, when you see it's clearly visible that this point is not the centroid of whole this area, correct? When you mention, when you find that you see this whole data points, for this whole data points, can you consider this point as the centroid? No, clearly not, right? There will be another centroid. Okay, there will be another centroid, so we will consider that centroid here. We'll consider that centroid here, and again we will perform this operation. Again, then we will perform this operation, because it's clearly visible that this is not the centroid of this cluster. Hence, the centroid has to be moved here. So this centroid could be identified again using the Euclidean distances. Okay, so if you want, you can write programs for that. You can use a library, something like that. But logically, this is how it is going to work. So once you identify the cluster, and then you find the new centroid, and again, when you see here in the second cluster here, when you see in the second cluster, for example. Sorry. When you select the second cluster here, that is this red cluster, you can see that this is not the actual centroid of this cluster, so it has to be shifted somewhere here. It has to be shifted somewhere here, correct? So if you consider this new centroids, what you have to do is, for example, if this point is x1, x2, and this point is the new x1 and x2, then you again have to perform the operation which we did earlier. So what was that operation which performed earlier? That was calculating the distances, between these two centroids. So you have to perform this operation again and again. So when you perform this operation, then it will be assigned to a new cluster. It will be assigned to a new cluster. So basically, each time when you perform this operation, the new cluster will be formed. Okay. So how long, you have to perform this operation? Your question must be that how long you have to perform this operation, because you cannot just go on find new centroid and do this operation. So you have to perform this operation until there is no change in the data set. For example, these points, when you consider these clusters here, right? When you can consider the new centroid here, then when you're going to measure the distances between this centroid and the data point, then you will obtain a new cluster. You will obtain a new cluster. So this is the newly obtained cluster what we have here. This is the newly obtained cluster what we have here. So in this newly obtained cluster, you see, you will again find the centroid. You will again find the centroid, and we will verify. We will verify whether this centroid is the exact centroid. This centroid is the exact centroid of this cluster. Okay, so now the question is when to stop this operation, because we know that you can form a cluster and you can identify the centroid of that cluster, but when to stop that? So we will stop it when the data points are will remain in this within the cluster itself. For example, when I consider this new cluster here, that is the blue one and the red one. Okay, and for example, imagine that this is the new centroid which I have reassigned, and then again I will calculate the distance between this data point and all these data points. So from this image, it is clearly visible that whatever belongs to red stays with red, and whatever belongs to blue stays with blue. So in that case, like, I mean, these data points do not move to the other cluster. But whereas, like, I mean, when you have considered here, these data points, for example, like this data point was closer to the blue, centroid, but it was not the case. Like, I mean, because when this centroid of this cluster was reassigned, then the distance, got increased, and it turns out, like, I mean, the distance between this data point and the blue centroid maybe is larger than, or the distance between the red centroid and this data point. Hence, this was belong to red. But when I came to some, after so many iteration, maybe like, I mean, on 3 or 4th iteration, I came into this stage, and here it is not clearly, like, I mean, moving the data point to another cluster. So that this is the point where you will, stop the clustering. So this is how we, like, I mean, we perform the clustering operation. Now, you might already have a question that, like, I mean, I said that, like, I mean, I started, talking about considering that, like, I mean, we'll consider two, some random, k points, random k points. But how do we know that? If you already know that, like, I mean, your data has to be categorized into, these many numbers, then you can go with that. Okay. Or else, like, I mean, what we will do is, like, I mean, we will go with, random k points, and, like, I mean, we will perform this operation. So it is an iterative process, and we will find out, okay, because we will find out, there's something called, we will find out the sum of squares within the clusters. Okay, using this mathematical calculation, like, I mean, we would be able to identify the the distances between this centroid and the data points. Okay, so by performing this operation, like, I mean, you will obtain for each, consider, for example, like, I mean, you have considered the random k point as 2, and you got a sum, a different sum. And when you consider another, a random point, like, for example, like, I mean, you consider 3, k with the k value as 3, and then when you perform this, you would get another WCS value, that is within cluster sum of square value. Okay, so you can note down all the squares, and after that, like, I mean, when you plot the WCS scores with the number of clusters whatever you formed. For example, like, I mean, I formed a single cluster, 2 clusters, 3 clusters, 4 clusters. I will go on and go on, and then because this is an iterative process, and then here I will find out the WCS score. And when I plot this graph, this graph will always end up into an elbow-shaped graph. So either it could be like this, or it could be like this, but there would be a deviation. Okay, so this graph was, like, I mean, all the way coming down, and this is the pivoting point, like, I mean, where this graph is not following the pattern, like, I mean, it has been deviated into another form. So you have to consider this point, and this point is known as the elbow point. So this point will be considered as the turning point, and this will be the best number of clusters that you can form in the k-means algorithm. Okay, so basically, like, I mean, when you have to see the maths, then, like, I mean, we will be calculating the mean of the distances, and that is how we are going to identify the new cluster, and we finalize that. So that, hence the name, k-means. Okay, any questions? Yeah, Harish has some questions. I know what it is. Okay. Oh, yeah. So the name here is because, like, I mean, we would find the mean of this data, and this what do you say, for example, like, I mean, this clustering can be applied to a two-dimensional data set or a linear data set, which you might have worked with. And when it comes to a two-dimensional data set, like, I mean, I'll walk you through the examples and like you will have more clarity. Okay. And even it can be applied to a linear data set, and we can even identify the clusters within them. So the name, why we have this means here, because like, I mean, we are going to consider the mean of the distances, and that is the reason why we have the name, k means here. Okay. So this k-means clustering, like, I mean, for when you look at the summary, like, I mean, the k-means clustering goes through like, I mean, 4-5 steps. So this is the basic steps, like, I mean, which we have to go through. So for example, like, I mean, when you see here, the first step what we have to do is you have to choose the number of k clusters, like, I mean, choose the number of clusters. Yeah, then once you find that cluster, you select that many. For example, like, I mean, if you have chosen, like, I mean, 2 random points, or the value of k as 2, then that will be the clusters that you're going to form. Okay, depending upon the number. Is there any point in defining the value of k as 1? The question was, I mean, see, we are talking about defining the value of k, or maybe the number of clusters. So if what will happen if you define the number of clusters as 1? When you define the k value as 1, what will happen is, like, I mean, you will only have one centroid here. So that means, like, I mean, the entire data will be categorized as 1. So the k value will not even start with 1. So we'll always start with the value 2, because, like, I mean, you will have 2 or more clusters. Like, I mean, there is no case, like, I mean, if it's one cluster, that is the data set itself. Data set itself. So if you have to use maybe, like, let's say, like, I mean, you have to always use 2 or more clusters. And how do you identify what is the suitable number of clusters is through the method called the elbow method. So how do you identify the elbow method? You'll identify the elbow method by finding out the within the cluster sum of squares. So within the cluster sum of squares implies that we have to find the distances between the cluster point 1 and the point data point here. So for example, like, I mean, this Wcss is an illustration of having 3 clusters here. We have, for example, like, I mean, if we have 3 clusters, what we are going to do is, like, I mean, we are going to find the Wcss score this way. For example, like, I mean, you have one cluster here, another cluster here, and another cluster here. Okay, so, and we have another data point here. So for somewhere, like, I mean, you have this data point. Supposed to change the color. Okay. This, we have to change this data point. We have to find these are your clusters. So this is your C1, and this is your C2, and this is your C3, and this is your data point, let's say, like, I mean, P1. Okay, so what we are going to find is, like, I mean, we are going to find the distances between P1 and C1. Okay, P1 and C1 squared, and then, like, we will calculate the distance between the P1 and C2 and P1 and C3. Okay, so when you calculate this distance, like, I mean, it will give you a sum, and that is known as within the cluster sum of squares. Okay, so for all this P points, like, I mean, you will be able to calculate the value, and at the end of this operation, like, I mean, you will end up with some number. Okay, so that number, like, I mean, that is what, like, I mean, you're seeing here. For some case, like, I mean, this number was somewhere around, the Wcss score was somewhere around 800. And for this point, like, I mean, it was somewhere around, when you select 2 clusters, the value was around 3000. When you select 3 clusters, the value was around, 1000. It does not mean that, like, I mean, the lesser the score of WCSS, more you will have more accuracy. There is, you will have a better clustering. There's nothing like that. It is always about, finding out this deviation, this pivoting point. So how do you find this pivoting point? When you plot this graph, you will be able to identify because, like, I mean, looking at this plot, you will be able to find out this pivoting point here and the deviation, and this will give you the optimal number of clusters. So this is how you will select the number of clusters. Any questions? Okay. So how do you run this? Like, I mean, I'm using a Google Colab here. If you wish, like, I mean, you can use your VS Code or Jupyter Notebook, whatever you need. Like, I mean, you can use that. So is there a Google Classroom or something created where we can share the files? How the files was being shared? Should I share it through GitHub? You guys use GitHub? Like, I mean, how do you share the data? In the previous session, like, I mean, was any data being shared? If it is so, like, I mean, how the data was being shared? Or else I can, put it in a Google Colab or somewhere, and you guys can download it. Sorry, Google Classroom or somewhere, and you guys can download it. Okay, fine. Maybe, like, I mean, the previous line I don't have used any data, but it is fine. Because, like, I mean, see, there are many ways, like, I mean, in which you can go with this algorithm. So for example, like, I mean, if you use scikit-learn provides a lot of data set in which you can download. But I would like to go with one sample data set, and I will share it with you. And it's not a big data set and not a relevant data set also. Like, I mean, not something very genuine, maybe like when it's fake, but I mean, it's good for demonstration purposes. Okay. So I what I will do is, like, I mean, I will just share, upload it in some collaborative space, and I'll share the link so that you can just download it. Give me a moment. I will just upload the file into a gist, and I will share it with you. I have shared an gist link here. Like, I mean, you can just access that, and you will get a CSV file. You may download that into your file system. If you're using Jupyter Notebook, you may have to upload the file into the corresponding working directory. Or if you're using any other IDE, you may locate that file and use it. Okay, so when you open this gist, so for example, like, I mean, this is the gist which you are going to use. So this, I think you can look into your chat box. Sorry, I'm texting to Entrance Electronics. I'll just paste it into form. You can open this CSV file directly here, and which contains some 200 entries, some random data set, 200 entries of probably about customers, which has got a customer ID and their gender and an age, and their annual income and their spending score. So probably this is something about how customers are based on their age and annual income, how they are spending it. So this data, this is the data which we are going to see, and this is the data which we are going to work on. So we are going to cluster this data into the categories. We will find out, in how many clusters we should categorize this into, or cluster this data into. And when we are done with clustering, like we will identify what are these clusters of users or customers looks like. So we will plot a graph also. So I want you to download this data. How will you download this data? Like you can just open the URL, and maybe you can just if you're using Chrome, you can just right click and save it as a CSV file. Or else, like if you use any command terminal, you can just copy this. You can wget the file directly. Somebody has a question, where can we access yesterday's file and recording? Maybe someone will from Entrance will comment on that. You can clarify with them later. Were you guys able to download the file? Download it as a CSV file. You can download it as a CSV file, save it as a CSV file. So this is the customer data which we are going to use. You can save it as a CSV file and you can upload it. Or else the easy way, or else what you can do is you can just copy all of it, open a notepad, and you can save it either way. So you can open a notepad, and here to my desktop, I'll create a now document, and here I'll just paste it. I will save it as I do not have the option. I will save it as a CSV file here. Okay. Okay, I'm already here. Open it as, I'll call it as a customer data dot CSV, and I'll just paste the file. Either way you can do it. Okay, I'm using Nano because I'm comfortable with. I used text editor. Turns out I cannot save the file into any other extension. Or else if you use this VS Code or something, you can use the same. So when you see in the document, I have the customer data here, if you can see. So after saving this data, you can just double click open. So probably it will open with your spreadsheet or Excel, whatever tool you use. So this is the data which we are talking about. So you should have this data somewhere in your drive, and I have saved it as customer data. So you should know what is the file name you're saving also, and you can upload. So what I'm going to do is like, I'm going to upload it into Google Colab. What are you guys working on? Like, you guys working on Jupyter Notebook, or I don't know. Yeah. You guys are working on Jupyter Notebook? Did you do you know like how to use the Python libraries, and because like we are going to code it in Python. Probably like which will involve a couple of plots, and also I might use matplot or Seaborn. Probably I will use matplot, and then we're going to do it. So I have chosen Google Colab because most of the time like this works out of the box. If you don't know like where to find Google Colab, you can just Google. You can type um, collab.research.google.com. So it will take you to Google Colab. So this is the URL. It will take you to Google Colab, and Google Colab is a space where you can run your Python notebooks, and you can run your Python notebooks, and even Google will provide you like 11 or 12 GB of GPU, and it comes with a TPU also. So you might have to use this when you're going to train things, because if you already know that like machine learning or when you go to deep learning, it's an computational. It uses a tremendous amount of computation. So hence we have to use GPUs. So this is the easy way to test your couple of things. Or else like there are other cloud platforms, maybe like Azure or AWS Cloud, and there are other optimized service providers. You can use them, but this is always free, and why don't we use this to get started with? Okay. So this is nothing but the Jupyter Notebook kind of interface. This is a notebook only, and here you can execute, and you can see the the connections, like whatever you are using here. You can actually see like where it is connected to. Once it has been connected, you'll be able to find out the connection details and all. Okay. So anyhow, I will continue with the same notebook, okay, which provides you, for example, I'll show you like which provides you see the RAM usage, GPU usage, everything you will get to see here. But for this example, like we don't need any GPU and all. We will just start with the CPU only. Once you have downloaded the dataset, what I want you to do is, have you downloaded the dataset? Yeah. So after downloading the dataset, what I want you to do is I want you to upload the file first. We'll first upload the file, and this is where we are going to upload the file. So my collab is reconnecting, and after once it's reconnected, like we'll get the file systems here, and this please note that all this file system whatever is being mounted here is temporary. It will not last longer. If you want to use that, you can use your Google Drive and use it in case if you're new to Google Colab. So here I'm going to upload the data. There are already like a couple of other data available for us to perform operations which we might use, but for this instance, like we are going to perform this on the data set which I have given to you because it is easier. Okay. So what we are going to do is like we are going to upload the data. In order to upload the data, what we should do is like we should click on this arrow here and select the file. So I have the file here called customer data. So we'll select that and upload it. Okay. See, it's clearly telling you that the uploaded files will get deleted when the runtime is recycled. That means like when you close this, or maybe when your session is over, like they'll recycle it. So now you have customer data.csv. I don't know in what name you saved the data set. If you save the data set in customer.data.csv, you will get the same. So here we have to import the we have to import the data set, and we have to start working on. So I think like you might have already worked with scikit-learn and other libraries. So we will start working with pandas, and we will try to visualize this, and then we will use scikit-learn libraries to perform the k-means algorithm, because it's already built in there. So the libraries what we need for this experiment is NumPy. We might need. I hope, where do we use NumPy? Import NumPy as NP. So what am I doing here? By writing as NP. File got saved in XLS format instead of CSV. The easiest way is you copy all of it, and then you just open a notepad. Okay, you can open a notepad in your system. You can just if you're using Windows, you can type Windows R and notepad. It will open up a notepad, paste it there, save this file as an old file, and give the extension as CSV. Or else, if you're using Ubuntu or any other Unix-based machine, maybe you can just open a Nano or Vim editor and save the file as .csv. Or else you can right-click and save. I don't know whether, because it is not possible here in Safari. I use Safari here, so I have this problem. You guys got it saved as CSV format. The extension should come as CSV only. I guess done. Were you able to get this file as .csv? If you're finding it difficult by this, I can share the gist here. You can share the gist, and you can download as zip. Probably it will download. See, I'll share this gist here. I'll share this gist, and here you would find an option to download it as a zip file. Download it as a zip file. So you can download this as a zip file. Okay. Download this as a zip file. And once you download this as a zip file, then inside that zip you'll find customer data.csv file. This way is also possible. So I'll share this link in the chat. I think you should if you have facing problems further, I think you should follow this link. You should follow the link which I pasted now, and you will find this download zip file, this button. So you can use this button to download it. To download as a zip file. For me, it has been downloaded here. So this is the zip file, and when you open this, so for example, when you open the zip file, see, it will have the data as the customer data. Got it? You can click this button. Or else, if you're using what do you say, this thing that is Google Colab, you can just copy paste the URL which I pasted earlier, not the current one, and probably you can run a command called wget. I don't know whether it will provide access, and when you run this, you should see the file. You see, it has been downloaded. and it downloads here, and you can reload this. You see, it will download it. Yes, this is also fine. If you're using Google Colab, I don't know, like, I mean, maybe you can, you know, if you're using any Unix based systems, I mean, these codes will work. Have you got the file saved in CSV now inside your Jupyter Notebook or Google Colab or whatever you use? How to save this Git file? Where do you want to save? See, if you guys can just type and open Google Colab, that would be much easier solution. And here you start a new notebook. Inside the new notebook, you just have to copy paste the following command, which I'm going to share it with you. Just copy paste the entire thing what I shared with you, and then like it will download the file. Or else you can just follow this gist link and download it as a zip file. Once it has been downloaded as a zip file, you will have this file inside and you can upload it. Either way, it is fine. I guess done. I hope like I mean you guys are done. Once you're done with uploading the data set, what we are going to do is we're going to import a couple of libraries. We're going to import a couple of libraries. So you might have already worked with NumPy. NumPy is a good numerical um, library, like I mean, which we can use. Like I mean, with the help of that, you can perform numerous matrix operations, or it's basically a short form of NumPy. That's been NumPy. And the mathematics of performance of operations can be done much more easier and faster in NumPy. So we need NumPy. I will import NumPy as NP, just a shortcut, so that I can use this reference NP to access all the classes and functions written inside NumPy and perform them. So I need not write NumPy every time. I just write NP. And similarly, since we are going to work with this data set, that is a CSV file, like I mean, we can use a library called pandas. So we will use pandas library. So we will again use the shortcut as PD. It's giving the syntax suggestion because Google is smart, and this is most commonly used references. And then we will use matplotlib dot pyplot. We'll use it as so we can again access the matplotlib's pyplot functionality as PLT by calling the reference PLT. Okay, so these are the three libraries which we need at the moment. After this, I'm going to execute this. So maybe like I mean you can just make a note of it, like I mean what I'm doing, and maybe you can say loading the libraries. but which you are already familiar with. You can just execute this. So these libraries have been, imported now. Now the next thing is like what I have to do is I have to read the data set. I have to read the data set. What is your data set? Your data set is this. Now you have to read it. So I'm going to create a variable called data set, and this data set. What do you obtain this data set? So normally, like I mean, in Python, if you have to open a file, then you will have to write the file operations, and then you have to load this. But you will have to write a lot of code just to read through this file. So Pandas gives you the flexibility of reading data from a CSV file, Excel, PDF, or whatever the file it is, like, and it can process it very well. And if you know how to handle it, it's much more easier. So there's a function called read CSV. So we will use the library called pandas pd, and we will call the method here that is read CSV. See, it can read a file from a pickle bracket or see JSON HTML. Like I mean, there are so many formats. Like I mean, which from where it can read the file from. So, but our file is currently in CSV format. If your file is in Excel format, you can again use that. But I mean, since our file is CSV format, we will use read CSV function. And here we have to mention the these parameters are already here. You can just read and understand and proceed further. So the first parameter what we have to pass is we have to pass the file path or a buffer. So we already have a file inside this directory. Okay, so we can try passing it directly there, or else like what you need to do is you need to provide the location. For example, you kept it somewhere, and then you have to give that location as somewhere, or else you can give the online data set also. I think it will read. So we'll just copy this and you can paste this also. Okay, so that will be your data set. You can paste this also, and then you can mention an index column. The index column is customer index column. Index column. You can mention an index column that is customer. What is customer ID? So customer ID. Okay, because like I mean we have seen that, right? When we opened it, we saw that it is the customer ID. There is a customer ID, and this is the index of the data. So we select as customer ID. Okay, and you can just run it. So it will select. I mean, you don't have to download the files, but in case if you have downloaded the file and uploaded, I don't know whether if your network is not allowing and all, then the best way is like I mean have the file locally and read it. So in either you can directly paste the link which I provided, or else you can use the file which you uploaded and you can provide the file path. So here I have uploaded the file path, so file here, so I can just copy this path. See, I can copy this path and I can pass that path here. Okay, I can pass that path. So now we have the data set. Now we have the data set. Okay, so if you want to see what is the data set, okay, we'll just check what is the type of it. So it says it is a pandas, not data frame. It is a pandas data frame. So what we are going to do here is like, I mean, we are going to create a pandas data frame here. And from the pandas data frame, if it has been converted into pandas data frame, we can perform a couple of operations which pandas will allow. For example, like, I mean, you just have, it is in 200 entries long data, which is not at all long when you consider machine learning and the other applications. But here, let's consider it is long because I mean we cannot display all the 200 entries here. So if you just want to peek into the data, what you should do is you can just call the data frame which you just created, that is data set dot head, data set dot head. Okay, data set dot head. So okay, somebody is in the lobby, that's so data set in the head, then it will list, the first 5 entries. So it's showing that, this is the data set which we have loaded. So it has got a customer ID, a gender, which is written as gender, age, and an annual income, and the spending score. Okay. So let us see, what are the information about the data set. If you want to find out more info, you can just, call the function called dataset dot info. Dataset dot info. This is the method. It will give you the information about this data frame. So it says that, it has got, four. It has got 4 columns here. The first column contains gender, and this column has been, avoided because we have specified this column as an index column. So pandas know that, this column do not belong to the data set, but it is the column which we can use for indexing. Okay, so your column 0 is the information about your gender, and the column 1 is age, and column 2 is your annual income and the spending limit. And it specifies that, you have no null content, this many non-null content. I think, Adarsh might have given you an introduction about data pre-processing, where you clean the data when you get it, and how do you pre-process the data, scaling and all might have mentioned. So here, luckily, I have selected a data set which do not needs to be cleaned, and hence, we have 200 non-null count here, and you can also see the data type of those elements. Here, gender is characters here, so hence it is mentioned as an object, and all others are integers of 64 bytes. So that's what you're getting to see here. Okay. And then what you're going to do is, we are going to find out. There is another operation called dataset dot describe. Okay, dataset dot describe. It will give you a lot of information about the min max and standard deviation, mean, count, everything. It will give you about the column wise. Okay, so the min of the column is this much, and the max of the column is this much, and the standard deviation, and so on and so on. Okay, but just to get an overview of this data. Okay, and we can also find out, whether there is any data that is null. Okay, if there is any data that is null, so you can find it out by this function dataset dot is null. Okay, and then you will get it what row by row wise, it will tell you if there is any null element. And if you want to see if there is any null element in a big data set, you can just call the sum. Then it will tell you how many data are null. So you see, in our case, none of the data is null here. Okay, so that means we do not have any null data. If there is any null data, then we will have to replace it with the corresponding data. For example, we'll mostly replace it with true or whatever. Okay, so for that's why we are checking the data. So now that we know your data is clean, now what we are going to do is we are going to select the data and identify the key features of the data. So here you can see that we have a spending score and an annual income. Spending score and annual income. So when you are going to categorize these users, you can categorize the users based on their spending score and their annual income. So in order to do that, what we have to do is we have to create this X variable. So how do you create? We are going to create an X variable here, which will have these two columns, which will have information from these two columns. So how will you do that? Function, and you can create this, you can select this data out of this entire thing, and maybe we can use it, okay, for easier prediction. So I'm just going to consider, these two columns here as the parameter, and we are going to spread this out. That's what we are going to do. So for example, like a person who's having an annual income of, $15K dollars, that means $15,000 as an annual income, then his spending score is somewhere around 39. Okay, so maybe this is the information which we got for a mall. And here, based on their income itself, we can categorize these people or cluster these people into, three or more category, maybe five or more category. We don't know. So maybe we can categorize them into, super spender, or maybe those who spends less. And based on this details, we can categorize these people. And this data can be used for the mall to provide offers. For example, if the users are, super spenders, they earn less, but they burn most of the money, then you can categorize those products. You can run offers on those products, which will be brought by with less money. And if your spending score, for example, let's say if you're earning less and if your spending score is low, then probably those people will not buy something, but they might occasionally buy some luxury product or something. So maybe in that case, this data will be useful. So this is how we are going to consider. So what I'm going to do is I'm going to consider an X here, which will have the data of the annual income and their spending score. So what I'm going to do here is I'm going to X, which I'm going to get it from data set, and I'm going to you might have come across this ilog function, right? Okay, so here I have to select all the rows. I have to select all the rows, but only annual income and the spending score. So what do I write in ilog? In ilog, I have to mention the information range of the rows. So I need all the rows. How do you mention all the rows? You can just mention it by an column. So it will select all the rows from start to end, and then you have to mention the columns which we have to select. Either you can pass the column name, or you can pass the column indexes. So what I'm going to do is I'm going to pass the column indexes here. So what is the index of a column for annual income? So your gender. So here, if you see here, your gender is column 0, age is your column 1, annual income is column 2, and your spending score is column 3. So we are interested in the data which belongs to column 2 and column 3. So we will pass this information here, column 2 and column 3, and then what we will do is we will get this value stored in a variable X, and this is what we are going to perform operation on. So for example, we'll perform we'll try to get this. So we'll see what is X. X is still a data frame. You see, X is still a data frame. When you check the type, X is still a data frame. It's just that it has been localized this value, and we cannot perform operation on a data frame directly. What we need to do is, we need to convert it into a NumPy array. So in order to convert that, we can just pass this values, then it will convert the X's into an NumPy array possibly, which will be easy for us to perform a mathematical calculation. So which has been converted into a NumPy array. You can see here. Okay. So you have to select all the X's, followed by dot values. When you take this, all this data will become NumPy array. The value will remain the same. So when you check this, it will be, you see, it is a multi-dimensional array here. What you're seeing is a multi-dimensional array, because which contains data of 2 rows. Then 200 rows and 2 columns. So that is a multi-dimensional array. So here you can see, this is called a row 1, and this is row 2, and this is row 3, and so on. Okay, so this is the data which we are trying to cluster. So for example, maybe we can try to plot this data if we need, and then we can perform this operation. For example, let's see if we can plot this data. How do you plot this data? I'll just delete this. This is not necessary. Are you following along, or is there any place which I want to explain more? This is just basics, right? Yeah. Okay. I'm seeing some response. So I think like I should proceed further. So now we have selected this data. We selected this data here. And now what we should do is like either we can just plot this data. Shall we try plotting this data? We'll try to plot this data then. Okay, we're going to plot this data as how do you plot the data? That is because we have already included the matplotlib library, and there is a function called plt.scatter. Okay, scatter takes two parameters, that is x-axis and the data on the y-axis. So I'll do x of what should I do? X of all which I have in row 0 and x of which I have row 1. Okay, we'll just see how it comes. See, this is the data which we are looking at. When you plot this data, this is how it is looking as. Okay, but we cannot even cluster this. When you go this approach here, how you will have to manually calculate all the distances, right? And you will have to, you don't even know. But looking at this plot, what is the assumption you have? How many types, in how many ways, you should categorize this data? Here you can maybe here. So all this looks like you consider start clustering, but we don't have to do that now, because we will be using those libraries which is built for that. Right. So we have scikit-learn libraries find out the optimal clusters. So how do you do that? So you should sklearn. So if you're using in your systems, you might be already and embedded. So will have in your system. Will be able to from we're going to import dot this should now execute without an error. Then the library has been imported. I think my internet is slow and it's taking a longer. It's done. Sorry. So the library has been imported. If you're getting any error, that means, oh, my voice is breaking. Probably that's because of the low internet speed. I have been experiencing some trouble since morning. Am I audible now? So what we are going to do is we have installed this libraries, and we are going to use it. So we have imported the k-means, and we are going to use this k. This is a class. Okay, so if you're going to if you're using a VS Code or some Jupyter notebook or Spider, any other IDE, you can press the command key and hover your mouse over this, then it will take you to the details. So that is this. So this is came in and we details there. Which we are using. I think my internet is having some trouble. Okay, you see, this is what the class looks like. This is the class definition, and here the parameters whatever it is taking is written here, and it has given all the information about the attributes that need to be passed or the parameters that needs to be passed, and all. Like when you can read it along and we can understand it a little better. Maybe I'll not explain most of it because I will explain only whatever the things which is needed for me. Correct? And there is an example code given here also. Maybe by following this, you can perform the operation. And there are a couple of methods given here also, and we are going to use most of it to identify we're going to identify the clusters. We'll use fit, and then we'll use fit predict. It will compute the cluster centers and predict the cluster indexes for each samples which we provide. So we can use most of it. So what we are going to do is when we are going to start using this. So here, after importing the library, what you should do is we should be able to find out the Wcss score. So what is Wcss score? For example, when you calculate, when you calculate the clusters. So the clusters can be found very easy because it's not a huge computational task. You can just call the k-means and you can pass the data and you can call the function fit. Then it will give you the clusters. But the main point of interaction here is that we have to identify the clusters here because we don't know how many clusters we need. Or how many clusters this data can be clustered into. So we will find it out by providing the by looking it into the WCSS score. And once you obtain the WCSS score, we will plot the WCSS score into this shape. And this shape will tell you which cluster will give you the better result. So we will find out this thing. So in order to plot this graph, we need to obtain the WCSS score. Okay, so if I have to obtain the WCSS score, what I have to do is I have to declare a variable here, WCSS. Okay, and this is going to be an array or maybe a list when it comes to Python, and this list is going to contain all the WCSS scores. Okay, so here we are going to run this k-means clustering. We are going to find out the WCSS score of a particular thing. So for example, I'll tell you how we do it. So for example, we have this k-means library here. So I'll say k-means equal to k-means. Okay. Of here we have to mention the number of clusters. We have to mention the number of clusters that's defined by n clusters. Okay, so here I say cluster number of clusters is 2. I say the number of clusters is 2, and then what you should do is you can just perform the operation that is k-means dot fit. We can fit the x value here. That the x is nothing but the samples which we have selected. That is the annual income and the spending score. Okay. When you perform this operation, you see it has been performed. Okay, and these are the default parameters which has been set. So the number of cluster has been defined as 2. That's what we set. and we can even provide the random state in order to increase the randomness. And if we are not setting it to and seeding it into the same thing, all of us might get a different result. And what is the the algorithm which is using, that is it can means plus will give you the better performance here. So hence, like we will use this, and so and so on. So you just have to pass this value here. So what we told k-means to do is, to cluster this data into two clusters. Okay, that's why ends the number 2 here. So this k-means will have so many parameters, sorry, so many matrices stored, in which one is you can identify the cluster centers. See, sorry, you can identify the cluster centers. So if you identify the cluster centers, you can see we have given the k-means. We told the k-means to pass the parameter, that is number of clusters. What we need is 2. Hence, it is giving us 2 clusters here. It's giving us 2 clusters here. That is where somewhere in you see that is where is 37. So let's see, let's try to figure it out, how it has been clustered. Okay, we are not going to plot it though. We'll just try to figure it out. So somewhere near, this is the x-axis value, somewhere near around 37 and somewhere near around 50. One cluster is found here. Okay, and where is the another cluster? Where is the another cluster? The another cluster is somewhere near 76 and 50. So 76 somewhere it must be here and 50 here. Okay. So when you are given the clusters, the data has been clustered into this. So probably it has been clustered like this. Okay, it has been clustered like this. Correct. So these are the cluster centers. Okay. So this will have the cluster center values, and along with cluster centers, what it has is it has got something called inertia. Inertia is the what we are looking at. Inertia will return the WCSS score. Okay, we can say inertia will return a WCSS score for this. So when you find these 2 clusters here, what is this inertia? Inertia is going to give you all the Euclidean sum of all Euclidean distance a particular point to a point, squares of the sum of a point 1 to cluster 1 and point 1 to cluster 2, and so on up to the 200th point. So you can even read it here. So let's say we'll see if it is here. See, inertia is sum of square distances of sample to their closest cluster center. So you get this. Okay, you get this. And this is what the WCSS score, which we explained earlier. So here you can see what is WCSS score. WCSS score is nothing but the distance between the distance to the closest cluster and that point, and that's what we are getting here. So what we should do is, this is for, when we found, so for example, when we found cluster 2, when we passed the 2 clusters, and when we pointed here, it was somewhere here. For example, it was somewhere here. Now, what I'm going to do is, I'm going to point it to, I'm going to find 3 clusters. I'll see, can I get 3 clusters? I can get 3 clusters. And here we'll again find out the cluster centers. Okay, we'll again find out the cluster centers. So earlier, if you should notice, the clusters were somewhere here. The cluster was somewhere here, correct? The cluster was somewhere here and here. Okay. Now, since for example, since we have given the clusters as 3, now the new clusters have been found. So the new cluster is somewhere around 87 and an 18. So that is here. They found one cluster here, and the another cluster is at 44 and 49. That is 44 here and 49 somewhere here. Okay, somewhere here, and then we have 86. So we mentioned here 86 and 82 here. So these are the 3 new clusters which has been formed. So when you look at it, maybe it has been clustered the data something like this. So this is one cluster. Oh, okay, this is one cluster. This is one cluster which is there. and this is another cluster which is there probably, and maybe this is another cluster. So this is how, like, I mean, giving cluster 3 has clustered, then giving the number of clusters as 3 has divided the data into, so segmented the data into, probably in a better term. And when you have given it as 2, it has clustered the data into these two forms. Clustered the data into these two forms, correct? So this is how it goes on, and each will have a different WCSS score also. But we don't know, like, I mean, till how long we should perform this operation. So what I'm going to do is I'm going to write an for loop here. I'm going to write an for loop here, and then we will perform the clusters here. And you would have an idea, like, I mean, to up to what extent, like, I mean, you should find the clusters. Like, I mean, there is no point in clustering this data into 200. Can you cluster this data into 200? If you cluster this data into 200, so that will become the data point itself, right? So you have to find out a minimum number of clusters that is possible for this data to have. So for example, like, I mean, if you cluster this data into 200 clusters, that will become the data itself. If you cluster it into 100, each cluster will contain 2, maybe, at a time, or maybe 1. So that's not an adequate situation here. So what we will do is, like, I mean, we will find out the clusters, maybe, like, I mean, we'll consider a number from 0 to 10, and we will find out the WCSS score, and we will plot the graph. We will plot the graph, and we will see, like, whether this graph is coming good or not. Okay, that's what we are going to do now. So what we will do is, like, I mean, we'll just write a for loop here, and we are going to append these values into a list. That's why I have defined a list earlier. WCSS score, that's what we are going to find out, and this WCSS score, WCSS will have the WCSS score here. So what we'll do is, like, we'll write in for loop for example, for I range, we'll start it from 1 to, it will go max up to 11. That's, like, I mean, it will go up to 10. And then here what we are going to do is, like, I mean, we are going to find out the k-means. Okay, it will be k-means, and here the number of clusters we don't know. We have to vary that, and we have to find out, right? So we'll mention number of clusters as I. So each time this loop iterates, then the value of I increases, right? Then what we have to do next is, like, I mean, we have to just that properly, and then what we have to do here is we have to find we have to call the function k-means.fit. We have to find we have to call the method k-means.fit. So what will happen by calling the method fit is, what will happen is, like, I mean, it will train. Okay, so let's say, like, I mean, what is going to happen, fit. So when you are going to fit, call the method fit, so it will compute the k-means cluster. It will compute the k-means cluster, and that's what it is going to do. So here what we will do is, like, I mean, we'll say k-means.fit, and here we will pass the values which we have in the data that which we have in X. Okay, and so each time, so for example, like, I mean, when the value is 1, it will have, because it will not start from 1, I mean, it will have and the 2, and then it will have WCS score 3, WCS score. That's what we are going to find out. So what we should do here is, like, I mean, we should append this result into WCSS dot append into the, what data we need to append here. We have to append the we have to append what data? We have to append the WCSS score. How will you get the WCSS score? You can obtain it from the inertia. K-means dot K-means. Okay. Confusing. Okay, so this inertia will give the score. So each and every time, like I mean, the inertia will up and the score. So let's try running it. And when we are done running this, like I mean, we will, how many entries will be there in WCSS list? When you're running this block, how many entries will be there in WCSS? Ten. Yeah, because like I mean, we are going to run it for 10 clusters. Okay, so let's see. So we're going to run this. Okay, so the initially, like I mean, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 clusters or WCSS value we have. Okay, now what I want you to do is I want you to plot a graph. Can you plot the graph with this WCSS value? And let us see, like I mean, how this value is being distributed. Can you try plotting it? Please try to plot it. I mean, I will definitely plot that graph, but I mean, please try to plot this from your end. You guys are doing? You try to plot that graph with and can you tell me once it is done? Then I will try to plot it from my end. Got it? Anyhow, I'll try to. I mean, I'll do it myself. Like I mean, but I wanted you to try anyhow. So what we have to plot? We have to plot a graph. Okay, we have to plot a graph between what? We have to plot a graph between this. For example, like I mean, we have to plot a graph between what? About. We'll plot a graph between the number of clusters we have. We will plot a graph between the clusters and the WCSS score. Okay, WCSS score here. So that's what we are going to plot. So in order to plot this, what we should do is, like, I mean, so for example, yeah, we should use matplotlib. Okay, plt dot plot. What do you want to plot? You want to plot clusters. So we'll generate clusters, range of, let's say, 1 to 11, and then we will plot WCSS value. Okay. Okay, so the plot looks like this. I mean, in order to get this more visibility, what we will do is we will try to set the figure size. Okay, we'll try to set the figure size. So quality dot figure size. We'll mention it as 10.5, and we'll plot. See? Now we have a little more clarity on the graph, and then what we will do is, like, I mean, we'll try to give a little color, so that will give you more interesting features here. So I'm going to, I want it in red color, and I want this in this data points to be highlighted as an node. So I'll just use this. So when you mention this, this data point will be highlighted like this. So looking at here, you can see which this is the number of clusters, right? I mean, this is cluster number 1, 2, 3, 4, 5, and 6, and 7, and 8, and 9, 10, 10. So here, which one is the elbow point here? Which one should we consider as the elbow point? Which one should be considered as the elbow point? 5th, correct. So we shall consider 5th as the elbow point, right? We shall consider 5th as the elbow point. Why? Because, like, I mean, looking at this graph, it's clear that, like, I mean, see, at the 5th, the graph is being pivoted, right? So we will consider the 5th as an elbow point. So we'll consider this point as the elbow point. So that means how many clusters will be there? How many clusters will be there? When you're done with the clustering, we should use the cluster as 5. Correct? The cluster 5 will be the optimal cluster that we can have. Will be the optimal cluster that we can have. Got it? Okay. So now what to do next? Now that, like, I mean, we know that this cluster having 5 number of clusters will define this data perfectly. That is, we can cluster this data into 5 regions probably, or maybe into 5 clusters. That's what we're going to do now. So what we will do is, like, I mean, again we'll run the k-means. So that will be k-means of here. We are in a position that, like, I mean, we can mention the clusters. What is the number we should mention here? Yes, 5. Correct? Why? Because, I mean, that is the optimum position which we found through elbow method, right? And here, maybe if you want, you can pass out the parameter. I'm not going to pass it now anyhow. And here, what I'm going to do is, like, I mean, I'm going to find the prediction of these clusters. That means I have x values. I have x values here, right? For example, like, I mean, I have x values. So these are my x values. So I should know, like, I mean, which class this belongs to. I should know which class this belongs to, right? So what do I call? Like, I mean, if I call the fit method, it is just being clustered, but, I mean, it's not telling me, like, I mean, which cluster this data point belongs to. Okay. Do you know that, like, I mean, which cluster the data point belongs to? Okay. Somebody has a question that is, we'll address that and we'll continue. So it's not showing k means object is not called in that for loop. So do not confuse yourself. Like I have used two type of notation here. So one is k means. I have used k means because I have imported k means, correct, and I'm using it here. And I have created an what is it? An object of k means here, and I'm created an object of k means here, and I'm calling those methods into that object. Okay, so if you have done mistake here, then you would probably get the error that is k means object is not callable. Can you check the code once again? Is it working now? Well, I think maybe you should you should see the references, like why it's happening, because this is the only place like which we have defined the objects, and maybe like you're calling it in a wrong place. So probably instead of this fit method here, in the fit method, probably you're calling k capital means. That is why you have the error. Okay. Please check this. Maybe you'll get it then. Okay. So here now it's clear that there are 5 clusters, and but we don't know which cluster this data belongs to. Correct. By calling this, it's only telling us what are the clusters. It's identifying the clusters. Okay. When you call the fit predict method, then it will predict the class or the cluster in which this data point belongs to, and this belongs to. Okay, so that's what we are going to do here. So for that, I will have an y. I hope you know, you might have heard about this x and y. What do you call x and y? In yesterday's session, Avinash might have explained what do you mean x and y. An input variable and an output variable, or what is the terminology you have used? Label and features, classes. Okay, anyhow. Yeah. So here, this y we can call it as the labels, and x we can call it as the input, because x is the input and y is the output which we get. Apparently, this is the label which we are going to have. Okay, so I'm going to store it in a variable called y predict. Okay, y predict is going to be where am I going to get this y predict? Okay, I'm going to get this y predict, or maybe you can call it as y k mean. Maybe let's name it as y only. Okay, let's name it as y. Y predict is y predict. It is going to be the k means dot fit predict method we have to call. K-means dot fit predict method we have to call. Okay, fit predict. Okay, when you call fit predict and when you x, let us see like what will happen here. We will see what are the y predict we are obtaining. Okay. This is because we should run this also, right? We will not have any k-means. We should have k-means. We should have here k-means equal to k-means of, we'll pass the number of classes here, also number of clusters. Number of clusters as 5. Why we are passing 5? Because that is the optimal number of clusters. And for the optimal number of cluster 5, we are going to find out what are the predicted values for each data point. Correct? See, when you do this, like this is the clusters that we are going to get. This is the clusters which we are going to get. Correct? And so for most of you, is this value coming same for you all, or else if you all want an unique thing, then you can specify a random state. So it will have an unique randomness for all of us. Okay, so this will select the data points randomly. This will randomize, but among us, that means I am sharing you this code and you're following this instruction. So for us to get it in a unique way, then we can pass this random state. So if you want, then you can see what is random state here. See, random state. Random state instances used to make the randomness. So we have to get an specific randomness here, because it shouldn't be very random. Because if it is random, you and me will end up having different results. That is why we have this different score. And same is the case here also. If you specify some randomness here, for example, some random state, okay, the random state, this number is what defines the randomness. Okay, so you and me are going to have the same score. So I don't know whether you have noticed this or not. When you are going to run this code, and when you're going to find out the within the cluster squared sum, then I don't know whether you and me were getting both the same result. But when you specify a random state and when you seed it to the number 42, not necessarily number 42, I just chose number 42, even it can be any number which should be common among us, then we all will have the same result. See, I can see, and hence it will also change slightly, and the values will have a slight difference. It will not be much. Okay, and here it will also have a difference. Are you getting it? Yeah. Okay. So that means what does it implies? This 3 means that there's a cluster, there's a third cluster. That means the value, that is the first value, initial value which we have, that is this value 15 and 39 belongs to the third cluster. Okay. Now let's look at the value 15 and 81. The value 15 and 81 belongs to the 0th cluster. That's how it has been classified or clustered the data. So there is no fun in seeing this data like this. What we have to do is we have to visualize this data. We have to visualize this data, right? How do you visualize this data? Can you try visualizing this data? How will you visualize the data? We can use a scatter plot to visualize the data. Can you try to do it? Can you try doing it? Yeah, I can surely do it, but if I do it, then you will just follow. But you try to do it yourself. I guess try. Yeah. So were you able to obtain a graph? How will you visualize this? Let's try to visualize this. How will you visualize this? So, for example, like I need a plot. Okay. I can define a definite size. We will start just by scattering this data. We'll start off with just by scattering this data, right? So what I have to do is I have to do plot scatter. Okay. What should I scatter? I should scatter x and y values. What are the x and y values here? So you can scatter it among the spending score versus the annual income. Spending score versus the annual income. How will you scatter this? You have to scatter x of 0, okay, and then you have to scatter x of all the rows and 1. So this is what basically we are going to scatter, correct? This is what we are basically going to scatter, but now we have to combine these labels also. We have to combine these labels also. Okay, so that's what we are going to do now. To do that, how do we combine these labels and scatter them? We have to scatter those x values which score is a 0, and we have to identify those they have to scatter here. So what we will do is we'll do this. We'll say x of y predict. Okay. So if the y predict is 0 and 0, then that will come here, right? That will come in this axis, and this axis it is going to be predict 1. Then we'll see what it is. Predict. See, these are those points. These are those points, which belongs to the class 0, which belongs to the class 0, right? So we will try to categorize them, and the remaining also we'll try to plot it like that. Okay. So what we are going to have is we'll do. So we are going to color them. We're going to color them some yellow probably. We're going to color them in yellow, and we'll label them as cluster 1. See, this is the cluster which we are getting now. Correct. Similarly, we have to do it for the other cluster, that is which starts from 1 0, and then like which goes all the way up to 1 1, and this will be what, let's put it in red in color, and this is also cluster 2. Now so because like you are seeing this because only we are plotting only those data which belongs to the category 0, and here only those data which belongs to category 1, and so you have to put, correct? So you have to finish it up to, let's say, 2, then it will be 2 and 1, then what we have 3. So this corresponds to like the label 3 and 0th column. This is label 3 and first column. Okay, if you have confusion, since you are not asking, if I was attending, like I would have this doubts. So let's say 5 and 5. When you cluster the data, okay, everything was yellow, so you have to change the color also. Maybe like we'll give blue, green. What other color shall we give? Blue, green, orange. Orange, and then what? So that's it. Let's give on some gray, sky blue, whatever. See? Oh, we do not have this category here already. We do not have this category because this we already covered all the clusters here. Cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. Correct. All these clusters. So maybe like we can just change this red color and we'll use red for the centroid. We have to mark the centroid also, right? So this is how the data has been clustered. So finally, at the end, like when you see this is how the data has been clustered completely. See? You can see this. This is how the data has been clustered. Just in case if you're wondering how the data is being clustered. So there are 5 clusters here. Okay, the yellow one, blue one, green one, gray one, and the orange one. This is how the data has been clustered. And why we consider this as the good one? Because like our elbow model tells that this will be the optimum number of clusters that we should consider. Now what we have to do is we have to draw one centroid. We already know the centroid of this clusters, right? So we'll try to draw this cluster. How do you draw the cluster? plt dot scatter again. We'll get it from the k-means dot cluster centers. Okay. First, for every row, like every row's cluster should be drawn here. So we will take the x coordinate here, and we will take k-means dot cluster centers. We'll take all the rows, and it's the first column. The column number 1 with index 1. Okay, and we can provide a color. So I would like to mention it in a red color. Okay, and probably like we can use a marker also if you want, just in case to see the highlight marker. Okay. Either you can use an asterisk mark or a box, anything we can use, and I'll just label this into Centroid. Let's see. label. It should be label. Yeah. See, but it is too small, tiny in size, and I think like we'll use this, and it is the figure itself is small. Like we'll try to set the plot size. Figure size. Let's give a matrix here. Let's see matrix. See, it's much bigger. Maybe like we can increase the size of the centroid. Okay, we can mention it as, let's say, 300. These are the parameters. Like, in case like if you want to increase this things also, like you can increase the centroid. Correct. So this is the centroid which we found, and like if you want, you can also store the legend. Okay, the other things, let's say. We can set a title. I think you already know how to do that. Let's say cluster of customers, and then we'll set the X label and Y label. What is being spread here in X? In X, we have the annual income, and in Y, we have the scores. So here it is annual income in $1,000, and here Y label. What we have here is we have spending score on a scale of 1 to 100, and then we'll show the legend. That's it. Y label. Y label. Okay, so this is how you plot the data. I don't think yellow looks good. We'll change it to what color? Black. So this is how the the clustering looks like, and these are the centroids, and so these are the type of users which we have, and we have clearly identified which user belong to this, and you can get it from this label, and you can cross check, and you can identify. I hope all of you are getting it right. Do you have any questions? There are also other matrices available, like you can identify the score of this model and other changes, which we'll talk about later. Okay. Yeah. So we'll go for a breakdown. Then we'll resume back after 15 minutes. If you have any doubts, please let me know. Are you getting the output? Do you want me to share the code or something? I can share this in a notebook to you if it's required. I'll share the notebook. You may please use it. I'll share it as a guest. I've shared it as the gist, so you can get as a gist here. This is the gist. You can access. I've shared the link in the chat box. You can access this gist and you can run it. Okay. We will resume after 15 minutes. If you have any questions, please. I'll wait 5 more minutes for question answering, and after that I'll break, and then we'll resume after 12:30. Welcome back. How many of you got the result for this? Now that I've shared this gist, so you all would be getting the result. So what I want you to do is, I want you to, do one more exercise. You can open Google Colab again, and here there is a famous dataset known for iris dataset, known as iris dataset. That's what we are going to do. So for example, iris dataset. It's a famous dataset. So you can see here. This is about iris flower. There's a flower called iris. So this is the iris setosa, versicolor, and virginica. So there are 3 types of iris flowers here. We have 2 here. Am I audible? Am I audible? Yeah. Okay. Yeah. So yeah, what we're going to do here is we are going to see there are 3 kind of flowers here, right? I mean, though this belongs to the same family, these are different category of them. So one is iris setosa, and iris versicolor, and iris virginica. So how do they differ in terms of their sepal length and the petal length and width? So these flowers can be categorized. So if it belongs to a particular a range of sepal length and petal length, then it would be classified as setosa, or else it would be classified as versicolor. It goes like that. So this is a famous data set that we normally play with. So what I want you to do is, I want you to perform clustering operation on this dataset. So this dataset can be downloaded using the sklearn's dataset, and you can read more about it here, and how it is done and other things. Okay, so basically, like, what we are going to do is, like, when we are going to load this dataset, it is even here also. So we are going to do the exact same step, and we're going to load this dataset, and we're going to see what are the items, and we will see, like, whether we can categorize or cluster this data into the given categories or not. And we'll see the results. So that's what we're going to do now. Okay. So initially, what I want you to do is, I want you to download the dataset using the library. So you can say from sklearn dot dataset import iris, load iris it is. Load iris. So there are other not many items here. The wine quality or not. I don't know whether you have used wine quality from here or not. Load iris. So we are going to use this. We're going to use this, and we will first again the. So I'm going to mention it as a data set, and data set is equal to load iris. Okay. So this will be the data set, right? So we'll say data set. We'll see what is this data set. See, this data set comprises of some information here, and it is giving you a description. It is a dictionary here, right? It is giving you a description. It has got a data and so on and so on. So when you select the description, when you select the description, this is what the description looks like. Okay, so it is saying that iris data set. Okay, iris data set, sorry, which contains 150 instances. 150 instances, 50 in each class. The number of attribute is a four numeric, a predictive attribute in the classes, and the attributes are following. One is sepal length in centimeter, sepal petal length, and petal width. Okay, and it goes on. Okay, so this is what we are going to use this data set, and this data set, in order to explore this data set, we will already have the data set and the labels. So from this data set, I'm going to extract data. Okay, so you can extract data from data set dot data, and you can extract labels from data set dot data set. It is data set dot target, and in case if you want, like label names, if you want label names, you can get it from data set dot target names, and we will try to print few of them. We'll try to print the label names. We'll try to print that. See, it's saying that it's Setosa, versicolor, and Virginica. So this is an array. So if it is 0, then it would be Setosa. If it is 1, it would be versicolor. If it is 2, it is Virginica. So we'll see the labels we have. So these are the labels we have. You see, the first 50. So the first 50 is your what do you say? The first item is your Setosa, versicolor, and Virginica. It goes like that. So anyhow, so we are going to use this data, and we are going to perform the operation on this. So here, out of this, let us see, what is data looks like, right? What is data looks like? So data is having a multi-dimensional array, which contains it would have 150 rows. It would have 150 rows, and then it will have how many columns it has. It has got 1, 2, 3, and 4 columns. It has got. Okay, so based on this is what we would we're going to do clustering operation on. Okay, so how do you define? How do you start with? So what are the libraries we need? We already have loaded the libraries, whatever we need. Okay, so can you tell me how do we cluster this data? Anybody, please? How do we cluster this data? The same way how we did with the old data. So we're going to cluster this, right? So how do we cluster? So in order to cluster this, what we need is we need to, uh, select the corresponding columns, which we already have here. Okay, so that is data set. So data set from data set, we have selected this data. So this data contains information about the sepal length, sepal width, petal length, and petal width. So using this, we are going to perform the clustering. Okay, and when we perform the clustering, what is the important thing? What we need to do? We have to find out the WCSS score, and we have to identify in how many ways we can cluster them. Correct? So how do we write the program for that? How do we write it? Can anybody say? I hope you guys are trying it. So what we need is we need to use the library. This is scalar. Okay, and from that we will import. Okay, using this k-means we are going to find the WCSS score. So WCSS score can be obtained. Okay, so this has been already defined. I'll reinitialize that. So the WCSS score list has been reinitialized. The next thing what I need to do is I need to run a loop, right? So I in range. We don't know. We are not telling that there are three classes. There are classes that has been classified. We don't know that yet, right? What we are going to do is when we are trying to give this job to the k-means algorithm, and we are trying to find out whether k-means is able to do this or not, and if k-means is able to do this, whether it is telling us 3 is the correct number of clusters it should have, or else. So that's what we are trying to do here. So what we are going to do is we are going to find the WCSS score first, and then we'll put an elbow plot, and then from the elbow plot we'll identify using the elbow method. We'll identify the optimal cluster. That's what we are going to do. Correct. So in order to do that, what we have to do is we have to run it on a loop. Okay, and then we will find out the k-means. So that's the same old way, how we did in the previous thing. Just that, the data set changed. N cluster will define it as I. Correct? And if all of us want to be in the same randomness, we can just mention the randomness as some into particular score. So random check 0 or something. That would be good. Okay. Then what we're going to do is we're going to k-means dot fit. We're going to fit, and then we are going to do WCSS score. We are going to append it, right? Append WCSS score. What is the WCSS score? K-means dot inertia, right? K-means dot inertia. And once we have this, I want you to plot WCSS. We will find out. Fit of data. Right? So this is the WCSS score which we have. Now you guys should plot this, and you should tell me, like, I mean, whether you're getting the correct, you are able to find the optimal in a cluster or not. Can you try plotting this information? I'll give you 5 minutes to plot this information. Tell me, like, I mean, which is the optimal cluster. And tell me how many clusters, I mean, what is the optimal number of clusters we should have? Yeah, but I replied three because you said that because you already know that there are three classes, or were you able to do it? Okay. Okay. So we'll try to plot it. How do you plot this? So in order to plot this, what we should do is we should type plt dot plot plt dot plot. Yeah, that's good. Plt dot plot. Then we will see it from 1 to 11, and then we'll plot the Wcss. It looks like this. Maybe we can add a bit of color here. Okay, maybe so B stands for the blue color, and hyphen and an O will tell the plot to have the nodes in a circular shape and the line. Okay, so like this. And if you want something in this shape, you can go with this. I don't think asterisk will work, but asterisk will also work. Anyhow, so this is how you do it. And if you want to increase the figure size, let's say figure figure size, mention something, let's say 2010 something like that. A bigger plot like this. Okay. Now, from this graph, it is clearly visible that, like, I mean, I'll set it to red and now from this graph, you probably know that, like, you see, the graph is going like this. And what is the elbow point here? Should I consider this as the elbow point or this as the elbow point? Which one should I consider as the elbow point? I should consider 3 as the elbow point. Why? Because that is where the graph is being pivoted. Because like, I mean, according to this fashion, it should have gone further down, but I mean, we see a sudden change there. And that is why we are selecting that point, right? So we'll select that point. And then we will, try to cluster this, and we will try to, visualize this. Can you guys do that? Now we know that, like, I mean, the optimal number, okay? So the optimal number of, let's say, the optimal number of what? Optimal number of chord. Optimal number of cluster is 3. Plot 3. Plot a plot the data to visualize the clusters. Can you guys do this? Try plotting this. I'll give you 10 minutes. I'll give you 10 minutes to plot this. If you have observed the from the previous thing, like, I mean, you would know, like, I mean, how to do it. Try doing it now. Are you guys doing it? Okay. So yeah, here what we're going to do here is like, I mean, we are going to, you know, visualize this, right? In order to visualize this, like, I mean, we know that like an optimal number of clusters 3. So we're going to use that and define the clustering, and we're going to visualize that. This would the task which we have got now. So I'll say k-means is equal to k-means, and we'll specify clusters. Cluster is 3, and we can set a random state so that like, I mean, we all are aligned. Then we'll get the predictions. We'll get the predictions. That is dot and do a fit predict of data. Okay. And here I'll try to find the predictions. Okay. See what it has predicted, right? I mean, it has predicted that these categories, like, I mean, which belongs to cluster 2, it has been clusterized as 2, but I mean, we can see in more or less in an order, like, I mean, it has been able to cluster the data accurately, almost accurately, like, I mean, and we will see like, I mean, what is the accuracy it has got. Okay. So after this, like, what we are going to do is like, I mean, we are just going to scatter this data. So how do you scatter this data? We can do it, right? PLT dot scatter. PLT dot scatter. How do you scatter the data? Can you scatter the data? Has anyone got the output yet? Are you guys connected? Hello? Has anyone got the output yet? Okay. So were you able to generate the predicted labels? If you are able to generate the predicted labels, I mean, you would be able to get those data also. So for example, like, what we needed to get is we need to get this. For example, like, I mean, we have this data here, right? Out of this data, this is the data which we have. Okay. So out of this data, what we need to do is like, I mean, we need to identify which one is which one belongs to the 0 and which one belongs to class 1, and so on and so on. So that's what we're going to do. So in order to do that, what we have to do is we have to, let's say, in order to do that, what we have to do is we have to call this. For example, like, I mean, we'll go for data of y predict as predicted labels. If it's equal to 0, 0. Let us see, like, I mean, what are the classes which belongs to that. See, the value which corresponds to 6.9, 6.7, these values belongs to class 0. That's what it says, right? So this is the initial value. This is the initial value which we are seeing here. Okay. So if you have doubts, like, I mean, I can write here. Let's see that you see the initial, like, I mean, whatever it was displayed as the class 0 it is, right? Now let us see, like, I mean, what is there in class or 1, because whatever the values which we have here is probably the class 1 values, right? So we'll see that. See class 1 values. So whatever we are getting here, we just been, because this data has been clustered into class 1. So hence, like, I mean, you see here 5.1, 4.9, 4.7, 4.6, all this data belongs to class 1. I mean, I'm talking about the first column of this data, correct? So that's why I have used 0 here, and 1 as the reference for the label which I'm passing. Okay, so it will filter out all the values which has called the label 1 and from the prediction. Okay, obviously from the prediction we are not touching into the target yet, and which is there in the 0th. That's what we are doing here. So using this, like I mean, we should plot it. So how we are going to plot it? Like I mean, we can plot it like this. For example, let's say, how do we plot this? In order to plot this, we'll do like this. We have the predictions here. We'll use this prediction and we will plot it. So in order to plot it, we have to do plt dot scatter, and here we have to get the data of y predict, which is equal to the 0th element and the 0th column. Then what we should do is, like I mean, we should that is the first element, x-axis. Now in the y-axis, what do you do? What do you scatter? You scatter data of, let's say, what predict belongs to the 0th column, and label 0 and column 1. Okay, so we are scattering them, in terms of this is what sepal length and sepal width. So we are scattering them into sepal length and sepal width. That's what we are trying to do. Okay, and here we'll see color. We'll mention it as green probably, and the label, we should give a label, right? What was the label which we have here? Which we had these labels, right? So let's see like what are the labels which we have. This data set dot target names. Okay, when you do that, the 0th class is set us up. Class 1 is versicolor and this is Bujiliga. So we can use that class information here. So here the label is label is Satosa, and similarly, like you have to do the we'll see for, and then what we should do well mention weekly blue gray. See, it's coming all in the same color because, like I mean, we should have changed these levels. So this is level 1 here. This is level 2. When you do that, I mean, this is how the items are being scattered. This is how the clusters clustering. Now, how do you add? Maybe like I mean, you can make it a little bigger. So now it is quite big. So this is how the data has been scattered, and like I mean, you can add the corresponding thing. Now, how do you add the centroid? We need to add the centroid here also. So how will you add the centroid? You can get it from there. Scatter. Okay. So we have the latest k-means dot cluster centers, and we need all the rows, and out of all the rows we need the 0th column here first for x values, And again the same thing. K-means dot cluster centers, all the rows and first column. Okay, and then I will mention some size. Let's say 100 I'll mention, and the marker you can set. Marker I'll set it as well. I'll set it as a block, and a color we mentioned as red. So these are the clusters which we are talking about. And if you want, we can show the legend also. Legend. Set us how was the color and which is. This is how you cluster the data. So now you know that, like, I mean, the data which belongs here, has been clustered into versicolor, and this data is Virginica, and this data is Setosa. That's how we cluster the data. Got it? Can you guys do this? Do you have any doubts so far? I guess done. So here, what I was trying to do is, like, I mean, I was trying to demonstrate with different examples. Like, I mean, we did it with some data which I provided, and we did it with some real-time data. And the same way, you can explore more, and you can do it with many other data. Okay. So if you have any doubts, so this is how you do the clustering. Like, I mean, just to remember, like, I mean, the steps you have to remember. What are the steps which we will do? We need to do. We need to identify the clusters. We need to repeat the task until the data point do not move from one cluster to another, and then you will have the cluster finally. But in order to obtain the number of clusters, like, I mean, you can find the WCS score by running it in a loop. So this will give you the optimal number of clusters you should have in the model, and then using that, like, you can perform all other operations. So this is how you do the clustering. Okay, so far in the last session, did you learn about classification? Like, I mean, I think like decision tree and logistic regression classification and other things might have been done. Did you learn about nearest neighbor algorithm also? KNN, K nearest neighbor algorithm. why I'm asking is because, like, I mean, I can show you an example of, a classification on image. So I thought of doing it with NLP, but I mean, again, it will be confusing. And on an image, like, I mean, would be able to do it. So that, like, I mean, I thought I will give you some hints on image also, because it's mentioned in the syllabus. So we'll try to cover that. So using a Canon, we'll try to build an facial recognition system, not a facial recognition system, probably a classifier. So you might think that Canon is an obsolete method of classifying, but which isn't. Like, I mean, it can be used for some tasks like this. So that's what we are going to do. So are you guys doing it, or have you done, or do you want me to send this code again? Or are you following along, or are you waiting for me to send this, or what is the status? You tell me. We'll proceed accordingly. Yeah, I'll again share the code by GIST, but it shouldn't be an a matter of just copying the code and doing it. I mean, you should understand. And if you are not following, I mean, you can ask me questions, and then I'll try to answer them as I can. Yeah. Yeah, that has been created an hour ago, 24 seconds. This is the latest. Yeah, this is the code here. You can use it. I mean, we didn't have to use the pandas and other things because it is already there. So I'll just share the gist. You can get it from there, and you can try running it on your system. It should work. And we'll continue here with the image processing. So what we're going to do is, like, I mean, we will be, running an face R cascade to detect the face on an image, and we will collect the samples, and with the samples whichever we have collected, we are going to classify the data between the classes. So that's what we are going to do. It's a classification example only. Okay, and it can be done using ANN also, and it can be done using other classification methods which you have learned. But being a Canon is the easiest one. Like, I mean, I will try to do it with that, and we'll see like whether it is giving us good result. That's what we're going to do now. Okay. So for this, we would need another tool called OpenCV. OpenCV is an image processing tool which is very famous. And if you ever came across images, like, I mean, you would have used it or heard the term at least once or twice, because it is such a brilliant tool. I mean, it can even run the device on an edge level to a bigger computer. So this is my main work area. I work for a company called Safran, and we develop aerospace and defense projects. So there we use OpenCV in an extensive level, and we do use edge devices, and we run our algorithms there. So mostly in OpenCV, like, I mean, we write codes in C, but I mean, which is very compatible with Python also, and it has got a very flexible library available. So we'll try to demonstrate that. Okay. And we are going to learn about how to use real-time data to and we put into this Canon classifier to get the classification. That's what we want to do. So why we are jumping into Canon, OpenCV already? Because like, I mean, we have to process that image just to get a few data. So if it is confusing, like, I mean, you can tell me and ask me questions, because this is going to be some completely new for those who are not came across images ever. So in order to use OpenCV, how many of you are using your Jupyter notebook, and how many of you are using Google? May I know that? Can you please mention it in the chat, because accordingly, like, I will have to give you instructions. So yeah, so if you guys are using Jupyter Notebook, I mean, you should have installed OpenCV. Do you have OpenCV installed in your systems? If you do not have OpenCV installed in the system, I'll suggest you to use, Google Colab, which is easy, and we can, run the code there, and we need to install anything. That's the beauty of it. I mean, even if you need a small installation, which can be done in, in a jiffy. So that's what we are trying to do. Okay, so I'll advise you to use OpenCV. So, related. Sorry, I'll advise you to use Google Colab. So I want you to open Google Colab. Once you open Google Colab, because like, I mean, if you're connected to internet, I mean, you can access Google Colab. So that's what I was wondering if you could. So what you can do is, like, I mean, you can just simply run the command called import cv2. Okay, so it will import OpenCV, and we would also need some library for NumPy, and we would also need some library for lib.pyplot. Okay, these libraries we need. We need these libraries because we are going to uh, use mathematical operations using NumPy, and we would display images using Matplotlib, because OpenCV is actually meant for the terminal-based processing, and it's not currently fully supported with the notebook. So if you have to show an image or not, like, I mean, it would crash. That's why we use Matplotlib here. So this is how we are going to progress further. Okay. How many of you are new to image processing? Maybe, like, I mean, I can explain a bit about image processing, like, in 10 minutes, and we'll proceed with doing these things. How many of you are new to image processing, or never heard image processing? Okay, there are a couple of people like five, five, six. Okay, okay, fine. So basically, like I mean, when you look at an image, so what you see is like I mean a composition of colors, right? What we basically see is nothing but the colors. So the problem what we have is like I mean every time when you take image, okay, every time when you take image, this image may be different at times, right? It may be different at times. For example, like let's say the light condition changes, the image changes, correct? Because it is representation it is a representation of pixels only, right? So for example, like when an image can be seen in multiple colors or in monochrome or in black and white, or that means grayscale. So an image can be basically, um, broken down into three categories. So one is a colored image, and another one is a grayscale image, and another one is a binary image. Okay, so tell me if you're not following that an image is nothing but you see in a matrix, right? You see a matrix, like I mean, it's an two-dimensional thing what you're seeing, an image. But when it comes to a colored image, it has got a depth. It has got a depth. That means, like I mean, it has got some color information. For example, like I mean, what we can see here is when you click an image, if it's a colored image, when you click an image and if it's a colored image, for example, like I mean, this is the image which you have, okay, and if this is the colored image, it will have different layers. It will have different layers. The first layer will be representing one color, the second layer will be representing another color, and the third layer will be representing another color, and so on and so on. So this probably this would be representing R, this will be representing green, and this will be representing B. So that means, like I mean, this is going to represent the what do you say, this is going to represent red color information. This is going to represent your red color information. This is red, and this is green, and this is blue. Okay, so this is nothing but what you're seeing as an image. Okay, this square, this rectangle, what you see is nothing but these three layers, composition of these three layers. So even if you're taking one point here, this will have this color information. This will have this color information. It will have a red color information. It will have a green color information. It will have a blue color information. Okay, so using this color information, this pixel is being represented. If somebody is being taken a photo, like I mean, maybe like I mean, that person is wearing a blue shirt, and wherever the shirt is being denoted, that part will be shown in blue in color, correct? So that's because, like I mean, those part has been captured in blue color. That part has been captured in blue color. Okay, so this a pixel will contain that color information. That's how it has been denoted. Now, when you take an image, an image will have, let's say, if it is this image is of by 100 by 100 pixel. If the image is of 100 by 100 pixel, that means it is going to have 100 pixel here. It's going to have 100 pixels. Each pixel will have different color information. Okay, that is when it comes to the colored color images. Now there is another color type of images, like I mean, which is a grayscale images, that you call it as a black and white image. In the black and white image, what you have is, like I mean, you do not have multiple colors, but you have one particular color and its shade, right? So in black and white, what you have is, like I mean, you have a complete black color, okay, and some pixel will be white in color, okay, and some pixel will be a partially darkened ones, correct? So that means this grayscale images is actually transitioning. If you take a pixel, it will be transitioning from a value 255 to 0. That means whenever the value of a particular pixel is 0, then that pixel will be marked as black in color, and whenever a pixel is having the value 255, it will be marked as white. Then in that case, like I mean, when there is some pixel which has been marked as 100, so it would be neither black, it would be neither white. What color it would be? It would be mostly some grayish color. correct? It will be mostly some grayish color. It can be, grayish white, grayish black, like, depending upon, like, which place it is closer. Because what we are seeing here is, like, on a scale of 0 to 255, on a scale of 0 to 255, correct? So in the scale, on the scale of 0 to 255, wherever this value is, the information will be denoted depending on that. So if it is here, it will be more close to black, and if it is here, it will be more whitish. So that is how, like, we denote this thing. Okay. So this is what grayscale images. Okay, I'll show you what is grayscale images. Okay. And there is other kind of images. There's other kind of images. Those images. What are those images? Those images are the images. So what you see, like, for example, like, there is an image here, and in this image, all these pixels can only have two values. Either those values will be 0 or it will be 1. Either those values will be 0 or it will be 1. What do you mean by that? If the value is 0, then those pixels will be black in color. If the value is 1, those pixels will be white in color. So you might have seen some images, right? Like, where I can show it to you here. We are on the internet right now. See. Okay. So these are binary images. You see what you see here. You see these are binary images. Imagine these are pixels, right? And some pixels is black and white. Some pixels is white and color. These are binary images. Okay, and this is a binary image. This is an example of binary image, because, like, you cannot see a gray color here. What you see is white. Okay, is white and black. Nothing but white and black. Okay, that is a yes. This is an example of grayscale image. You see, this image combination of white, black. Trying to do today is, like, we are so for that, initially we should understand three four the about Har cascade. Okay, so Har cascade has Har cascade is a classifier with so machine learning classifier. You will take another 1,000 images where you do not have balls. Okay, and then what you will do is, like, you will superimpose these balls onto this, the object you want to detect, right? Like, you those images onto the non-native images. That means, like, you do not have balls, and you will create this data set and you will train it. So this training will help us to identify when there is an image in the object in the image. Hello, is my voice breaking now? I mean, I just saw the messages. Is my voice breaking now? Okay. Let me know, like, I mean, if my voice is breaking. I do have an issue with internet. I mean, I'll try to switch it to another channel, like, I mean, if there is an issue. Okay, so what we will do is, like, I mean, we will superimpose the messages and we will create this hard cascade. So once this is an example of one hard cascade, correct? So what you see here is an example of hard cascade. So it has got data. It has been trained with thousands and thousands of images of a face. So wherever there is a frontal face, you see, this is trained using an AdaBoost algorithm, and it is a front face detector. So this hard cascade classifier can clearly detect where there is an image, where there is a face in the image, where there is a face in the image. So that is what we are going to do first. Okay, then we will collect the samples of those faces and we will categorize them into two, and then like we will store those images. That's what we are going to do now. Got it? So in order to do that, what I want you to do is I want you to download this hard cascade into your file. So I'll just send you the link, then you can download it. I'll just share you this link. Copy this. I'll paste it in the chat box. Somebody messaged, no sir, I did not get it. Is my voice breaking, or I don't know what you mentioned, no sir. Okay. So you can open this link. You can open this link. Once you open this link, you'll get an option to download it. You can just click download. So once you click download, it will be downloaded. So you can see my file has been, hard cascade file has been downloaded. So once it has been downloaded, what we will do is, like, I mean, we will again upload it here. We'll again upload it here. So that is hard cascade here. Download. I have a hard cascade here. You upload that. Okay. So it is somewhere around 2 to 3 MB in size, maybe. So it might take some time. Now it's just 900, less than a KB. I mean, less than an MB. So we will use this. And the next thing what we need is, we need a sample image. We need a sample image. So maybe, like, I mean, we'll take an image of a famous person. Whom should we take? Any suggestion? Whose image we should take? Can you suggest me a person of, then I can take the image of the person from Google Images? Give me some suggestions. Arnold? I should take Arnold. Is there any other suggestion? Just one Arnold? Elon Musk? I think Elon will do. Yeah. Elon Musk. Okay. Oh, Elon Musk is all masked up. So we need Elon's face, basically. We'll select a few images of Ellen and we'll see, like, where there's a face. Okay? Probably, like, I mean, we'll select this image. We'll try to detect whether we can, get the face area only, because in this image, like, I mean, since you and me are humans, like, I mean, we know that this image, contains face in this location, correct? But the system do not know. So we'll just upload that image here again. Elon Musk. Okay, we upload this image. We have uploaded the image. Now we have Elon Musk here. Okay, so now what we should do is, like, I mean, we have to read this image. So I'm going to say image, let's say Elon Musk is going to be cv2 dot imread. There's a function called imread which will read the image, and you can specify the path. So here the path is this. Just copy and paste the path. Okay, and then once it has been read, we have this image in Ellen. So if you want, I can just show you the type of that variable. Okay, you see that will be what's an untype? Didn't read. I clicked on another thing. I should have selected Elon Musk, right? Okay, and we'll see the type of Elon. See, Elon again is a numpy array because, like, I mean, it comes as this. See, when you try to display this, it will give you a multi-dimensional array. Can you tell me like how many dimensions are here? You see, 1, 2, 3. So there are 3 layers. These are the 3 layers of that images. Okay. So size of oh, how do you do size of dot size of okay, yeah. So we have this 3 layered information here. Now let's try to display this image. How do we display? plt dot imshow. Okay, there's some function called imshow in matplotlib. We'll use that and we'll say ln. Sorry, we'll try to do ln. Okay, we'll try to do ln and we'll see the result. See, but the image is being displayed, but it's not displayed in the correct format. I mean, because there's a shift. Okay, so we need to adjust that. How do we adjust that? We can adjust that in such a way that, like, I mean, we will if you have to see this in true color, what we need to do is we need to convert it into a proper color. So we have a function in CV2 that is CVT color. Okay, and then here you need to pass the image. Then you will pass CV2 dot the color format you want it to be converted into. So the image has been read as a BGR. That is why this information pixel is being displayed like this. So we need to convert into BGR to RGB. Okay, when we convert it into BGR to RGB, image is not there, so it should be ln. So it should be ln, and ln will be converted into the true color. Now we have the true color of ln here. So this is how we display an image. And there are other operations which you can perform in OpenCV. For example, like, I mean, if you want to extract one color, okay, so let's say ln, we want to convert into grayscale image. Okay, we want to convert into ln into grayscale image. So we'll do this. We'll say cv2 dot, okay, cvt color, cvt color, cvt color. It is ln to what color? cv2 dot color bgr to sorry, which it should be bgr to gray, right? bgr to see? Now we have another object created. We'll try to display that. plt dot imshow. That is gray. Okay. See, now we have ln in gray in color, because again, like, I mean, we have to pass this parameter here. cmap plus gray. Okay, I have to search. Okay. Gray only. Okay. So maybe there was a typo probably. Like, I don't think this is required. Even without that, it should work. Yeah. Gray. Okay, it was gray like this, and I typed the spelling as GRE gray probably. That's why it was not coming. Okay, so now so this is how you convert an image into one form to another. So now when you check out this value here, when you check out this value here, for example, like this has been converted. When you check the value here, you see the what is it? Just call that gray. Just call that, and you can see earlier, like when we displayed this image here, displayed this image, that is LM. So it had multiple dimensions. See, it has 3 dimensions. Now we only have 2 dimensions because dimension has been reduced here because it has been transformed from colored image to grayscale image. That is why we have reduced this image. And when you look at these values, so this contains 3 layers, as I mentioned. This contains 3 layers. So for example, like if you want to combine the layers as this, let's say red, okay. So if you want to get that layer alone, then what you should do is you should do alone of we need all the layers of all the rows and all the columns, but we need the 0th layer. Okay, E blue. Okay, E blue should be right. Of all the rows, all the columns, and one, and E green. Okay. And of all the rows, all the columns, and 2. So if you select this, this will separate all the rows. This will separate all the elements. So here what we should do is like we can actually combine this and now create it as an image also. So let's say like plt.im show, and when you display this image, it will not come in red and gray in blue color. It will only come in gray color because it will have less information. I'll just show you that. E-red. So when you display this, I'm just going to display this information. You see, this is the which is containing the red color information, and wherever you are seeing, the extreme bright portions are the one. Let's say extreme white portions are this image. This is the gray image and this is the red image. Do you see the difference? I don't know whether it is visible in the video, but I can clearly tell the difference because you look at this color of the face. This color of the face, he is much brighter here, and when it comes to here, it is not that bright, right? When let's say let's check out the green color information. Sorry, green color information. When you check the green color information, you see this face is much brighter than the original grayscale image. So this is because it contains the pixel informations are distributed like that. Okay, so this you can go into this level and identify, but that is not our first priority. We have to identify where our face is located in the image. That's what we have to identify. In order to identify that, we're going to use hard cascade frontal default cascade filter. So using this filter, we will pass this image using this filter. Then it will identify that particular area, and then we are going to collect samples and we're going to perform operation. That's what we're going to do here. So now that we have, let's say, that what we have is, so we have yeah. Now that what do we have? We have the images of this person. Now we have to identify the face. So for that, we will create an R cascade filter. So you can create a filter like this, face cascade. Cascade. We are going to create it from cv2 dot cascade classifier. We'll use this cascade classifier, and we have to pass this path here. So this is the file which is going to create the cascade classifier. So this I remember, like, I mean, around in yeah, if it's a face detector, then so here you as an example. I mean, not necessarily everybody is using that. In my observation, I think this is most easiest way to implement. And I will create an hair cascade filter. So using this filter, we detect that face of the image. So what we are going to do is, like, I mean, we are going to pass this face into the filter. Then we will obtain the points where the face starts and ends. Okay, so that's what we are going to do now. So we'll say face coordinates. Face coordinates. We are going to obtain this face coordinates by face cascade. Face cascade dot. There's some function called detect multi-scale. So we'll use detect multi-scale, and we'll pass the gray image. Okay, that is ln underscore gray, and we have to pass the fine-tuning informations. Okay, so here when you press this, like, I mean, you can actually see it is going to give you the when you look at this detect multi-scale class, you will identify it. It will take some more fine-tuning information. So I'm just going to pass this value. This is the zoom gear values, and once you pass these values, you will have this coordinates. Okay, so you will have this coordinates. Now you have this coordinates, right? Like, I mean, let's say we'll see face coordinates. What are the face coordinates that we obtained? The face coordinates which we obtained is 338. Okay, one is 338, another is 67, another is 159, and another is 159. Correct. So this is 338. You see, where is 338? 338 will lie somewhere here. Okay, this is 338 will lie somewhere here. Correct. And it starts from there. And another one is 67. 67 will start from, for example, like let me draw it here. It will be much more better. See, 67 would start somewhere from here. Correct. That point 67 and 159 it is asking for 67. Okay, and this is 338. 338 would be somewhere here. Okay, and another is what is it? 159 somewhere there. And then, like, I mean, when you mention this, like, I mean, this is the point where it is going to tell you, like, I mean, this is where the image is. Okay, so let's try to draw this now using the coordinates itself. That's what we are going to do now. So we'll do that. Oh, we'll do that. We'll do that. Okay, so how do we do that? What you have to do is, like, you have to draw a rectangle around that. We'll say cv2 dot rectangle rectangle around the ln gray, and here we need to pass this coordinates. Here we need to pass these coordinates. So for ease of use, what I'm going to do is I'm going to take it as X, Y, W, and H. Okay, X, Y, W, and H. That is, this will give you the coordinates. Okay, so I'll tell you like, I mean, how it is like coming as 159. So we have to calculate from here. Okay, so phase chord 0 X, Y, and here we have to pass the first point. So we are talking about the first point. In x-axis, we'll talk about the first point. This is the xy axis, right? So the first point is x and y. So we'll have to mention x comma y. And the second point will be x plus, this is x, right? X plus the width of the value, whatever it is. So will be x comma x plus, sorry, it will be x plus width, and the next will be y plus h. Okay, y plus h. And the third parameter that we have to pass is the color in which we want to do. So if you want it in red color, you should pass 255 and 00. Okay, this is red, green, blue. Okay, so the line in which the color, the color of the line in which is going to drawn around. And here we will mention a thickness. We will mention a thickness, and then we will use this IM show. Okay, IM show to show this image. CV2 dot CVT color of Ellen gray. Okay, Ellen gray, and it will be CV2 dot color VG2. Maybe here we can just draw it on Ellen only, right? Can draw it on Ellen. See, yeah, you see, this is where the Har cascade has detected the phase. Now you can clearly see this is the color information which we have passed, and hence it is correctly detected. You know, that particular portion. So using this method, what we are going to do is we are going to collect phase samples, and those phase samples, we will use those phase samples in images of maybe Sachin Tendulkar or some other guy, maybe like, I mean, your favorite actor, something like that, and you keep it in 2 folders. Okay, but it should contain face, not with the mask. Okay, it should contain face, and then we are going to use again a classifier to create a model to tell us that when you pass an image, the model will tell us whether that is the person 1 or person 2. That's what we are going to build. Okay, so we'll break for lunch now, and by the time you come back, I wanted to download and keep 20 images of 2 different persons. And it will be good that, like, I mean, if you select 2 different person, because this is not at all an optimal solution for face detection or classification, but just to make it interesting, I'm doing it on face. Okay, I could have done it in any other data set, but this would be an interesting data set to work on. So you guys can work on face data set, please select two distinct persons. If you are selecting twin or identical persons, our model will not work, because like we are going to train it for 20 images, and which is not a really good data to train on. Okay, so I want you to collect a 20, 20, 40 images of two persons, 20 for one and 20 for another. Okay, and I'll meet you after lunch then. You guys are unable to download Hard Cascade, then I will tell, like, I mean, you can just Google for Hard Cascade and you can get that. That's what I did, right? See, that's what I did. You can say Cascade face. You see, yes, OpenCV Hard Cascade available. Is this? Share. You can get it here. This is the example. Okay. Then I'll see you after lunch. You guys assemble back at 3 o'clock and we'll continue from there. Yes, what is the request, Adish? This background picture. Okay, so this comes as I updated back Mac Mixer, so it's the background of that. Okay, okay, and yeah, so yeah, you can just search for Mixer background, and then or wallpaper, so you'll get that. So yeah, so here we are trying to build a face classifier using Canon, and it is will be an effective thing. And I asked you to have some files downloaded. I hope most of you have not created this uh, data set. So what I will do is, like, I'll share the data set which I used in one of my training previously. I don't know your choices. So then you can use this data set which I'm going to share it now. Okay. So the data set which I'm going to share now is this thing. Just a minute. Share the data set. So I'm sharing you an GitHub link. You can just download that, and you can copy this. So which contains images of Vijay and Shah Rukh Khan. That's what I used earlier. So here, this is the data set which I'm talking about. So here, for example, like we have this data set here. It's like face data probably, and which will have some 160 image of Shah Rukh Khan and 160 image of Vijay. This is what we are trying to use now. So if I have shared this link, or else like this is the npyz file. I will share you another link now. But do not download the one which I shared right now. this um, so, um, or else I can just well, I think the link has it been shared? If you know to not I think I should reload this. Yeah. I think it's done. Let's wait till it is connecting to the machine. I mean, my internet speed is very poor. I don't know what happened today. Yeah. And after connected and visualizing, we'll see whether we get all the files. See? Yes, so I do have all the files extracted here, and these are the images. One is the Shahrukh, and another one is Vijay. So all the files are being extracted in the corresponding folders. So I hope you guys are following along. Now, what is the next step we need to do is reloading. Okay. Now, what is the next step we need to do is we need to just files have been inflated and extracted in the corresponding folders. Now, what we have to do is we are trying to create, and I hope you guys know who these actors are. Vijay is one Tamil actor, and Shah Rukh Khan you already know. So we'll try to display a few images of them. So let's say I am Vijay. So I will create a variable and load a JS image cv2 dot I am read, and let's say just a minute. Yeah. So am I audible, guys? Okay. So what we are trying to do is we are just trying to display some image here. Like we'll see whether you recognize those people, and then we'll progress further. Okay. We'll say, and I don't know what is the English name given. That's one.jpg and so on. Okay. One.jpg. Then we will try to display that. Let's clearly dot and show and Vijay. So this is that Vijay actor Vijay, and similarly you can display the other person. So now that means we have all the images loaded here. As for example, if we want Shahrukh here, say, We'll try to display Shahruk's image. So Shahruk's image is also already here. So I've selected, some, it is the same repeated images. So like 5-6 images is only there, and I have populated the database to have some depth. So what we need to do is, like, this apparently this image is having the head, but not necessarily all the image will have the head only. Maybe like, when you move to like 21 images or something, it may not have all this 20 images having the same thing. Okay, you see, like, there are different images, faces here. So I've used, and we will run through a face cascade, and then using the face cascade, we will store this data set. That is the whole idea of this. So in order to create, like, what we are going to do is we are going to create write a small script, so which is going to iterate through all of these folders and directories, and it's going to create and generate an NPY file. This thing, but the numpy file for these corresponding features. So that's what we are going to do. So we are going to say face data. Let's say, like, we'll just create a list, and I'll use some variable here just to iterate and like just keep a count of it. So what I'm going to do is, like, I'm going to say for item in range. I know that, like, I have 160 items because I have created the data set. So I have to go up to 161. Okay, and here, so each time, like, each time, like, we are incrementing this number. So I can, or else, like, directly use the item also. This is not even required. So we'll say image equal to cv2 dot im read. So it's going to read from, first of all, like, we will do it for Shahrukh. Okay, so from the folder Shahrukh, it is going to read, and I'm going to concatenate the item. Concatenate the item. Okay, the item, then plus the file name dot jpg, and then like, I'm giving -1 so that it will read in full color. Okay, and then we'll convert the image into gray. Convert the image into grayscale. I hope you remember, like, how do we do that? cv2 dot cvt color, and insert that will convert the original image into grayscale. cv2 dot color bgr to rgb. The reason why we are using BGR, because we are writing BGR, because it is being read in blue, green, red format. Now here, what we are going to do is, like, we have to convert not into RGB, we have to convert it into gray. Once you're done, now the next thing is, like, we have to find out the cascade. So we'll say faces or a single face, like, whatever we have. Is equal to face coordinate, basically, where we have to find the face coordinate. So we will get it from face cascade, which we defined earlier. Face cascade dot detect multiscale, and here we'll pass on the gray image, whatever we are using, gray. And there are other parameters which I'm passing, that is zoom, shear, range. So using which, like, we can adjust the face detection. Okay, and now I have this data here. So what I'm going to do is, like, I'm going to crop this image out of that this entire image. Now that, like, we have this image here, for example, like, this is this image we have here. So in this image, in this image, like, this entire picture is not our feature area of interest. We are only interested in this area. We are only interested in this area. So we will get this face coordinate. We will get this coordinate x, y, and the w and h. So the w and h. So using which, like, we will be cropping out this image. So that's what we are going to do now. So in order to do that, what we will do is, like, I'll just run I'm just going to wrap this XYZ coordinate around it. WH and face COD. Okay. Face COD. And here I'm going to crop the face. Sorry, I'm going to crop the face. Okay. And I'm going to mention it as cropped face. So how do I get this image? Like, I mean, I'll get it from the image. That is this image which I have selected, and I need to select a respective area of that, image. For example, like, I mean, I'll show it to you like once I'm done with this. So here I'm going to crop this image. So here we'll mention it from, we have to crop it from Y to Y plus H, and then X to X plus W. Okay. And then we will resize this image. Resize face probably. And how do you resize? There is a function cv2 dot resize. cv2 dot resize. And here we'll pass crop face. And we are going to resize this image, all the image, whatever the image, into 50 by 50 pixels. Because like, I mean, we just need that much information. Then what we are going to do is we are going to append it into face data dot append. Then we will append the resized face data. We'll append the resized face. Okay. So that means like when this loop is executing, it is going to iterate through all the images inside the listed directory, and it will scan all these images, and then it is going to generate and so it will going to append all the data into this thing. Now once we have this data, the next thing what we have to do is we have to what we have to do here is we have to generate the NPY files. We have to generate the NPY file, or we have to save this file somewhere, so as like we can use it later. Okay, so we'll say face data is equal to np dot as array. So this function will let you to save this face data, whatever which you have, as an numpy array. It will be saved, and we can generate an output using np dot save function. And here we will name, we will save it with the name. So we are going to save it as let's say I'm going to save it as this is Shahrukh. So I'll say Shahrukh. Okay, Shahrukh Khan, and then we'll pass the data which need to be saved. Okay, so once you execute this, it is going to iterate through all, iterate through this folder. It is going to generate a Shahrukh.npy file. You see this? So this file has been generated. So you have to do the same thing for the other guy also. You could have created it as a what do you say, a function, but yeah, it doesn't matter. I'll just copy paste this and I'll repeat the step. Any doubts? Any doubts so far? Okay, so we're going to repeat the same step for the other day also. And here we write today. We will just input this and just run it again. Okay. See, should one more. You see, we have got like 2 files generated here. So this is how you generate this thing. Now, if you want to create a face data, and since we are working with Jupyter Notebook, and even in my, you can write program directly from your so you can modify it. If you need, maybe at the end I will share that code also. I don't think so. Now once you have this data set prepared, now we have this data set prepared. The next thing what we do is we will see like that has been for example, like this is a you upload enter Vj.mpy. Okay, so the become an numpy array. Now we'll run it again. So once you run it, we in an with this day will check the shape of this. So when you check the shape of this diamond, and okay. Now it says that let's say 60, 50, and 3. So it means this it has got 160 images. It's 50 by 50. All these images are colored images. All these images are colored images because you would have noticed that, like, I mean, when I'm cropping the image, crop the image. I use this grayscale image only for me to obtain the face darkest. So once I dark cascade, so if you want to see, we can execute this plt dot I'm sure. Let's say J is this. Okay, so you say some number 45, 50 image you want, all the rows and columns and the depth you need. That image. See, it has been recreated that image. It's just the face you can see. Like now, this contains only the face, okay, which is of size 50. Yeah. So that means, like, I mean, we have our data set here, and maybe, like, I mean, if you check with Shahrukh, and then you will get the same. So anyhow, once it is there, the next task which we have to do is, like, I mean, we have to create a data set. Now our data set is half complete. Okay, that is, like, I mean, we have data set of Shahrukh and we have data set of Vijay. Now what we need to do is, like, I mean, we need to have a label also. We need to have a label also. So where do you get this label? So you can have this label and you can create this class ID and other things. So for that, like, I mean, we will just load these things into an NumPy array, and we are going to process it and as it is. So what do we do is, like, I mean, we will initialize a few data. So I'm going to initialize a face data. Okay, face data, and then we will create some labels. So all this is going to be array, and then we will have a class ID for each of the element we will have class ID. For example, maybe if Vijay is being detected first, then we'll assign the class as 0 to Vijay and 1 to Shahrukh. Okay, and then we have other variable dictionary to store names. Okay, we will map it with the ID. So in order to automate this, what I did is written a small script here. So for some effects in OS dot, we are going to list the directory, but this is not required. For two data, but I'm just demonstrating. Okay, so here you have to see where this NPY file is. Copy the path. We're going to scan the entire directory. And then what? Okay. 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 Am I audible now? Okay. What we are going to do when we are going to generate these labels, once the label has been generated, we'll see the rest now. So let us see, like when let's run this block of code now. Okay. Content is not. Oh, OS is not important. So it has Farooq and Vijay. Then what we are going to do is like we'll just see like what are the labels generated and other things. Okay. So here um, we will see the class IDs. So since we have only two, like it's going to be two. So we'll see the names what is being generated. So names ID 0. The class ID 0 will be Shahrukh and class ID 1 will be the so this hence this is the label. Like let's see like what is the label being generated. Labels. So labels like see first 160 images. 160 is this 0 and another is this. So we have this thing generated and we have the face data also, but it is not in a uniform shape. So what we will do is like we will flatten these two together and we will concatenate these two arrays. So as you can see here, this array is separate and this array is separate. This is not. This is more or less like the data being like this. So you have 160 images here, okay, some 160 image and another 160 image you have here, and you have the corresponding label here, okay. But we don't want this. Like what we need is like at the end like we need a 320 images here and the corresponding 320 labels here. So this is what we want. So that's what we are trying to achieve here. So in order to get this, we have to flatten this thing. Okay. So the next operation which we are going to perform will be flattening these layers. So we are going to do this face data. The face data set we are going to concatenate both all the face data whatever we have. Concatenate. We will concatenate the face data we have along axis 0. Okay. Axis 0, and then we will concatenate the labels also. Face labels. It is again concatenate np dot labels axis 0. I mention axis 0 because like come one after another. Like when once this will start on a in a single column. That's a row after row. Like we need to reshape this also. We need to leave this. That's what we will do. And after that, we will just bring the face data set shape, and we will also bring the face labels. I will see how it goes. this. Oh, spelling mistake. Okay, so now we have, there's what elements in data set. That is like, earlier we had VJ, so another 160 in altogether we have 320. Okay, now we have these two values. So this is going to be your X and this is going to be your Y's. Got it? I mean, this is how we are going to work now. Okay, so now what we need to do is like, we need to combine all together, these two together, and we have to make a training data set. So we are going to create a train data set, train data set. So this train data set we create by combining both of this. Concatenate, whatever we are going to concatenate, we're going to data set and coordinate the phase labels. Okay, and this we are going to concatenate this, 1. So axis 0 means axis 0 will be like, this, axis 0 is this, and axis 1 will be, along the side. Like, if you have multiple tables here, and if you're mentioning axis 1, then like this data will get added here. And if you're mentioning axis 0, it will get added here, like this. Yeah. So here we'll see like, how to do it. Then we have to mention in which axis we have to axis. And now we'll again see but there shouldn't be an issue. 2320, what did I miss? Okay. Technically it should come forward. Unfortunately, this should have. Yeah. You guys can take a 10-minute break. Like, let me see. Like, let me figure it out, and then we'll continue. I guess still there. Hello. Okay. So anyhow, so the concatenation is not. I'm not getting it. Like I mean, there's something went wrong. Okay. So now, I mean, what we do have is like I mean, we have the training data set. Though, like I mean, we have not separated them into training and labels. So we will use this training data set to train the model. That's what we have to do now. So in order to train this, what we will do is, so in order to train this, so what we have to do is, like, I mean, first of all, we have to write an KNN. So either like you can use the existing KNN, or like when we can just define the KNN from scratch. So I think like I mean you guys know like I mean what is basic KNN algorithm. So KNN is a classifier. So the KNN algorithm works based on the distances between the data points. So it is based on an Euclidean distance only, and the way it works is like I mean wherever like I mean this the data sets is closer, like I mean we will find the Euclidean distance between the data sets, and then we will be categorizing them into the classes, whatever the classes which we have. So for that, first of all, like I mean we will have to write a function to find out the distance. So the distance we will find it from vector 1 to vector 2. So this is the input which we are going to give, and this function is going to return the square root of the square root of v1 square root of v1 minus v2 v1 minus v2 the whole square and we have to sum all of it. Okay, so this is the distance like I mean which we have calculated, and here in order to write a KNN, like I mean we can write it as for example, like when we're going to write an KNN, like when we're going to pass an train data set, and we will have an test data set, and then it will have the value maybe like let's say k equal to 5, and then we are going to have is like I mean we're going to so the value of this k, like I mean you can alter and we can get the better performance of this classifier. Okay, so we will consolidate the distance in an list, and for that like I mean we are going to run a loop. So that will be train dot whatever the size of the train, like I mean we will have to we will get the vector and the corresponding labels. So this is what we are going to do now. So here what we have is like I mean we have to get the ix and iy. So since we are going to pass the train data set here, we will be taking the labels manually. So we'll say ix is phase data set. I think I have not flattened the layers. That's what happened. This is like this. I should have flattened these layers. Just flatten this. We have flattened this data set, and then after flattening the data set, hopefully, we can generate that train data set. So train data set can be generated this way. That is. Data set. Levels. Axis 1. We just flattened this. Okay, we didn't save it. Okay. Now we have maybe we missed a step here. Yeah. Okay, now it will work. Okay, so the problem what was happening earlier was like I did not flatten the layer, matrix is there. So for size 4, size, and this is of size 2, and hence it was not a concordant. Anyhow, like now when you do this, and then it should concordant. Yeah. So now the train data set has been created, and after that, what we should do is we should get we should not mention train data set. Here we should get it from the train data set only. So this is what we are going to do now. In the train data set, what we So in order to get the images, that means like wherever like our image data, the 7,500 pixels are there. So we will get it from here. So in order to get that, like because this is the last column, what we will get is like we'll get it from train of the corresponding index, and then we will select all the way up to the last. Okay, and then similarly, like we will have an IOI. IOI will be the label. Get it from train of I, and all the way last. Okay, so this is but all the way up to the last, but this is the last one. So we will have the label here, and we will have the training data. That's what we are doing here. Okay. And after that, once we have this training data here, the next thing is we need to find out the distance. We will find out the distance using the distance function which we have already defined. Distance. So this distance function will give you the test point. Will give you the will give you the distance between the test point and to the IF, and then it will we will keep loading it into the distance list here. Okay, and we'll keep loading into the distance list here. Distance list here. Okay, so here we will have the distance and the corresponding label load. So this is an implementation of Canon from scratch. You can do it without this also with the help of sklearn also, like you can use it. But I just wanted to show you like how we can even build a Canon model from scratch. Okay. And after that, what we will do is like we will have to sort the distances. Here, this distance will contain all the distances between the test point and the trained data. So it will have the distances kept in this dist list, and from the dist list, like what we are going to do is we are going to sort out the distances, and we will select the shortest one. Whatever the shortest comes, like that will be the class it belongs to. So we will say some sorted. How you are going to sort the distance, and the key will be like we have to lambda function here. We are going to pass a lambda function. So this lambda function is going to return the sorted value. Okay. So it will sort all the for example, like it's going to sort the items. So when you sort, like on the top, like you have you have given 5 items. So it will select all this 5 item, and these 5 items will be your the classes, highly probable classes. That's what we are going to do here. And then what is next thing which we are going to do is, once the sorting is done, then we will retrieve the labels from the sorted list. So we're going to retrieve the label, that is labels is equal to np dot array from the sorted list. We will select the last. We'll select the last one, and then we will get the the frequencies to of each label. So in order to get the frequencies of each label, will return the count, like how many it has been uploaded, and then we will have the index. Okay, we will find. Hope you know what is the argmax function. Using the argmax function, we will find the class. That's what we are going to do. And then we will return output the inlet. Okay. So this is the scann function. Using the scann function, like I mean, we will be able to, uh, you know, train our model and get the output. So let's say there is something went wrong. Oh, so it should be lambda. Now our function is ready. Well, the next thing what we have to do is, like I mean, we uh, read an image. So this model is ready now. So we are going to pass this, data in image. So in order to do this, like when what we should do is we should get the image first. So let us say, like I mean, we will download one image. Download this image. This one. So just one. The bigger image. Duplicate the image here. Now we have the image here. So what we will do is, like I mean, this data was not used for the training. So what we are going to do is, like I mean, we are going to pass it to the account. So in order to do that, like I mean, we'll say new data, data. New data is nothing. We are going to read this data. cv2.imread. And here we will pass the file name. This. So this data will be read. Now, once this data has been read, in order to test this, like I mean, what we have to do is, like I mean, we have to again pass it to the face, because there should be a face, and we the existing model whatever we have. Okay, so we have to convert this image first of all. We will convert this image. Let's say new gray. We'll convert into grayscale. That we'll do it with cv2.cvt. This is the same operation which we the same operation here. cv2. Then we have to change it into grayscale. Once it has been changed into the grayscale, the next thing what we have to find is we have to find out whether does this have an image or not. So we'll say new coordinates. We'll have to find the new face coordinate. We will get this face coordinate from face cascade dot detect multi-scale, and here we have to pass and with a shear scale of 1.3 and 5, and then what we should do is, like when we should we'll get this new face coordinate. Okay, So we'll get this new face coordinate, and from this new face coordinate, what we have to do is like we have to send it to this can. We'll see. So here, for example, this is the new face coordinate which we have got. So we'll do IM plot, so IM show of this image, this image. This will be new data. Okay. So you can see that like this is the image which will, and we have got a face coordinate. What we are going to do is like when we are going to crop the face out again. So we will again use this XY and WH coordinates, and then we will reset and flatten the image. So for example, what we will do here is let's say new face is going to be, we'll first draw a rectangle around this image. So this is going to be new data, and here we should pass the parameters. So it is going to be it is x, y, w, and h. This is face coordinate. That will be new f4. Then console multiplier. So now we have this, and here we will use this to build across the image xy, and then we'll use x plus w, and then x y plus h, y plus h, and then color has to be mentioned 255 and 255 if, and then we'll show that image. Okay, so new face. See, this is the a rectangle which has been detected. Now what we do is like we have to crop this image out, and we have to pass it to the CM. That's what we are going to do now. So now this face image has already there. So what we are going to do is like we are simply going to crop this image. Okay, so it will be here. It should be here. We'll just run it, and we'll get this in place. Then we have this. Should be what we need to do is new face is equal to new data of, we will crop that image. What we need to do is like we need to go for y to y plus h, and x to x plus w. Okay, and then we'll again try to plot this image. Okay, so this is the face which captured from this new image, and this is the new data. So what we should do is we should pass this image into the Canon model. So in order to do that, we have to resize the cropped face. So now we have this cropped face here, and which is an original image. Now we are going to resize it. So we'll say new resized. Then it will resize it using cv2.resize face, then we'll specify the size. Hope you remember we resized earlier into 50-50. Now what we need to do is we need to get an output. So the output we will get from the KNN function, which we have. And here we have to pass the train data set, and as the test, so we have to pass this new resized, okay, resized image, and we have to flatten that. Flatten. Okay, then it is going to give us an output. Okay, so the output image will should give the predictor name. So the predictor name will be, we will get it from names. We have a dictionary called names. Then we will convert it into the, we will pass it to this names. The output, where this will output a value either 1 or 0. So we'll pass it here and we'll see that. That's what we are going to do. Okay. Went wrong. This should be output. See, we have we have got the this thing as Shahrukh, so it has been predicted. So this is what I was trying to demonstrate. It has been predicted by our KNN model. So you can even save this KNN model. If you use an sklearn, then you can save this KNN model and you can get it predicted. We did not. This image was not used for training, and we passed this image and we have passed it into the new resized as the new resized image. Hence, our model that was able to predict or classify this image as Shahrukh. So if you want, you can do it for this Vijay guy also, which we have trained him. So we'll see. So Vijay is so many images are there. Probably this is some new one which I have not used for training, and I'm not sure whether it's going to detect with beard, because most of the images which I used was without beard. So probably I'll use this image, maybe something like that. Maybe I'll use this image, and we'll just copy this image address, and I'll just repeat this step here. Just a couple of things. And here, instead of this, I will get this image here. Okay, so we will have this file vijay.jpeg, so we can get that, and we will just follow the steps. vijay.jpeg, we load the image, we convert the image. Just to set it in a good format. We'll just use this. the image has been loaded. We'll see the loaded image here. See the loaded image is there. Then we'll find out the coordinate. Once the coordinate has been obtained, we crop the image. The image has been cropped. Then now we will crop it for this image. The system do not know this guy is, who is this guy is. So we'll just run it. It's predicting Vijay. So that means this scan is working. Do you have any doubts so far? Maybe I can share this file and you can test it for your own experiments. Any doubt? Anybody? Okay. I think that's it. We've tried to cover the a little bit of image processing. I don't know whether it went a little too extra, but I was just trying to show how we can get this face detection using a KNN working. So this is how you will get it, and I'll just copy this link and you can use this. Okay. If there is any doubts, you can ask, or else we can wind up the session. So I had a little of hiccups here and there because the code was not readily written. I was writing on the go, and so that's why I had something. You can even real time, if you see OpenCV, you can use it into real time detection, and it will still detect those people. Is there anything else that you guys need from me, or else we can wind up the session if you do not have any doubt?
Any queries? Okay. Sangeet Suresh, no. No query? Okay, fine. So can we wind up the session? So how was the session? I hope session was going excellent. But you tell me. Okay, good. From Harish side. Okay. Anuvinda helpful. That's great. Next. At least guys give your feedback. How's the session? Divya PV, it was a very informative session. That's really great. Akash, pretty good. Yeah, Amaya Prasad, outstanding. Okay, that's really great. So overall, like if I'm just taking, like I'm just come on a conclusion, like it's a good session. That's great. Okay, great. Okay, so I'll just do one thing. I'll just check your chat box.
Uh, yeah, I think it's like, I mean, we can wind up. I mean, if you do not have any further queries, I mean, I have shared the gist with you. Like, I mean, you can use it. And it was just a demonstration of, how we can, implement the things which we learned. And I just wanted to try it with images. And if it confused you, like, I mean, do not worry. Like, I mean, you can, even do it with the normal data sets. And this is a small implementation of Kern, and like, I mean, whatever is there in sklearn or any other library, you can even use, you can even write it from scratch, or you can even use the one which you have in the libraries, and you can get it done. If there is any queries, like, I mean, you can let me know, or else, like, I mean, we can just wind it off.